Good morning, folks. Welcome to SCaLE's MySQL track for 2019. How many of you, this is your first time at SCaLE? Wow. Well, this is like going to the Super Bowl for the first football game you've ever seen, and not like the Super Bowl they had a couple weeks ago, a really good interactive Super Bowl. My name's Dave Stokes. I'm a community manager for MySQL products. Oracle sends me around to evangelize on MySQL, and part of that is to show off some of the new things we're doing and talk about MySQL. I want this to be interactive, so if you have a question, raise your hand, I'll repeat it. By the way, we're being recorded, so if you're here on Witness Protection Program, don't look in the back of the room. There's a couple of people who are now shrugging. The slides will be posted up later. I'll have that on the last slide. By the way, there's a MySQL booth over in the expo hall that opens at 2 o'clock. Have lots of goodies, including dolphins. So if you don't get one now, by the way, you've seen it why I never made it as a sports. Oh, sorry. Yeah, I'm going to see it now. MySQL kills a customer at SCaLE. Okay. And we're talking today about the MySQL document store. This is a big revolution for us, and I'll go into a lot of the details in just a moment. First, a lot of you are wondering, is it MySQL or MySQL? Well, our former CEO, Martin D'Amico, said it doesn't matter as long as you're using it. But it's kind of funny, you find that it rubs people the wrong way if you're saying MySQL and they're a MySQL person. Most of the folks who work for Oracle will say MySQL, mainly because it takes longer. But I saw this cartoon a couple months ago and thought it was very appropriate. So, since I work for Oracle and we have a lot of lawyers we have to keep busy, we have the Safe Harbor Agreement. This basically states that if I'm talking about something that's not a released product, take what I say with a grain of salt. Until it's out there officially with a stock keeping unit and a price, even though it's open source, it's not fully developed yet, and I might leave off a couple features or enhance something that I shouldn't be enhancing. And today, I'm talking mainly about the MySQL Community Edition. This is the free version you can download from dev.mysql.com. Since this is a Linux show, this is what you can get with your distros. We do have a couple Windows or Mac folks in there. We do have downloads for that. And we do have a Docker container that's very, very popular. So, in the 1960s, they had a big trouble with data. Disk drives were very slow and very expensive. And a guy named Edgar Codd came up with structured query language and relational databases. Well, he didn't quite come up with them. He kind of one that synthesized everything together. The idea is you want to store your data in little normalized sets of data where you have things like everyone's zip code with another column of zip codes, customer addresses separated from supplier addresses, things like that. Worked very well. It's probably the only language from the 70s that was still going on very, very strong. But in the past decade or so, a lot of people are converting to things like key value pairs, like the old Berkeley DB for the folks here with gray hair, like Durhans, you might remember Berkeley DB, which is now SleepyCat, which is also an Oracle database. And a lot of people went over to the NoSQL side because they thought it was easier than relational tables. And in some way, relational tables are the best option out there. It gives you data integrity. If you have something that's marked as a decimal and you try to put a string in there, it will complain. It won't let you do that. You have your data normalized, so everything's nicely compartmentalized. You have like with like. It's very well organized. You can have constraints like foreign keys, where you can chain down various other tables to keep the relations going. You also get transactions, and that's a big thing for a lot of businesses. Make sure that you do everything in one step or you don't do it at all. And SQL, over the past 40 years, has become a very, very powerful language. However, there's a lot of setup you need to do before you use it. Relations, indexes, data normalization, all that just don't happen. You need someone to do that. And usually that's someone who's doing the work of a DBA, even if they may not be a DBA. And this is very, very hard work to do well. And the worst thing and the thing that probably had the most people go over to NoSQL, is it's very hard to make changes on the fly. You just can't instantly snap your fingers and have everything ripple through the system. Now, the NoSQL, here we're talking about document stores, not things like graph databases or columnar data stores. But document databases got really, really popular, especially with things like MongoDB. They're schemaless. You don't have to set up the relations. Very quickly you can start using them. You instantly start saving your data. Don't have to worry about the DBA setting up stuff. It's very flexible. It gives you mutability of your data. If you suddenly have a new piece of information you're collecting, you don't have to go back and have the DBA redesign the tables and push all those tables out and all that. And you don't have to worry about having to use an object relational mapper. Also, JSON is the current flavor of data interchange format that we all love. When I first started coming to SCaLE many, many years ago, we were still in the throes of XML. Those of you who are a little bit older might remember when everything was done in XML or SGML. Well, XML, then SGML before that. And long before that, we had the F-Sedict and ASCII wars for those who are really ancient. The weird thing about JSON is it's close to the front-end design. It's native in JavaScript, which means no matter what language you program in, you are also programming in JavaScript. So you're used to it. And it's fairly easy to learn. Now, the other thing is DBAs have evolved to see data in one format. The relational table, where you have information that references keys and other tables, and the data is fairly rigidly structured. Developers these days don't want that. They want to see something that's a little more loosey-goosey, stuff that can change on the fly, something that you don't have to have a DBA set up on the front end. So, our engineers a couple of years ago started wondering, what if there's a way that we could do both SQL and NoSQL at the same time on the same platform on the same storage engine, so that you don't have to have two sets of data, you don't have the redundancy, you just have everything in one place, and you use it as you see fit. If you want to use it as NoSQL before lunch and SQL after lunch while someone's doing the opposite, no problem. So that's where the MySQL document store developed. We see it as a solution for everybody. Developers get rapid prototyping and a very much improved API. They get the lovely schemaless document model, and they get transactions. Now, the DevOps folks are happy because this performs very well. It's robust. You have replication. And there's a comprehensive ecosystem behind it all. And as a business owner, and I just don't mean the folks who actually own the keys to the business, but the folks who are actually responsible for the day-to-day operations, you get transactions. You don't lose your data. You can do stuff on time. You don't have to worry about the roadblock of the DBA if that is your roadblock in your business. So you get the schemaless, flexible JSON document store. You don't have to use SQL unless you want to. No need to define all possible attributes for a table before you can actually start saving code. We have a new API that I'll go into in depth. And you can leverage generated columns to extract data from the JSON information and put it into a SQL table, and away you go. Now, there are some caveats. The JSON data type itself is limited to about 1 gigabyte of space in a column. If you need more space than that, use 2 columns. This is limited by the packet size in our old protocol. The new API lets you use modern programming styles in design. Once again, you're not having to embed ugly strings of SQL in your code. I think it's much easier to read. You'll see some examples later. By the way, this also works with relational tables. And best of all, for me and Michael, one of my counterparts from MySQL, this is all run on proven MySQL technology. So if you know MySQL, you basically know the foundation of it. We have connectors for all the popular languages, and we're building more all the time. Before anyone asks, yes, I know the Go one is in the works. I just haven't hooked up with the PM to find out where that is. If you don't see your favorite language on here, let me know. I can talk to him and see if we can get it on the list. Also, this comes with a new shell. The old shell has been around since the birth of MySQL, and it runs on our old protocol. Well, The old shell and the old protocol are kind of showing their age, and we decided to start over with a fresh, clean sheet. You'll see some examples of it later. What's really interesting for a lot of us old timers, it now has command completion. So if you don't remember what the arguments are to a certain statement, type in the first couple letters, hit tab, and it will show you the options. This shell comes with 3 modes. It has a built-in Python interpreter, a built-in JavaScript interpreter, and there's also an SQL mode. We're also using the new shell for a lot of admin functions. So if you've read about InnoDB cluster, if you want to see a demo of that, please come to the booth. You set that up with the new shell. If you're running MySQL 5.7, you can type util.check for upgrade and put in the host IP of your machine. It will tell you what you need to upgrade, what you need to change before upgrading from 5.7 to 8. We're trying to take a lot of the upgrade pains out. And the other idea is that we want you to think in the idea of a session, not a connection. Your application really shouldn't worry whether it's talking to one server or a cluster of servers or a distributed cluster of servers. Your application should be worrying about its connection. Part of this new model is it's built on non-blocking asynchronous calls. So if you have the need to send off 5 or 6 queries at the beginning of your application and grab that information as it comes back later while you're doing other things, you can now do that. And also we wrote this all around simple CRUD operations. Our engineering team was looking at, well, if we're going to do a new protocol, what do we base it on? And the thing that impressed them most was Google Protobuf. The great thing about this is, besides it's rapidly becoming standard, it also gives us a little bit of strict typing. Not terribly strict, but a little bit of typing on the protocol messages, which is going to make SQL injection a little bit harder to do. And once again, if you look at this format, it's JSON. This is a model of our architecture. On the left is our classic protocol and our classic SQL-based API, the standard protocol, talking to the server down below. Now on the right-hand side, you see the new X protocol and how it works with both CRUD and SQL APIs into JSON collections or the standard relational server. This is what we hope your applications will look like in the future. On the top left, your application will talk to a connector that will talk to a router. We prefer MySQL router. There's also other programs out there like Proxy SCaLE you can use. And that decides where to send it into a cluster or a single server. And off on the top right, you see that yellow box. That's our shell that does all the admin work. So what does this look like in real life? Since 80% of the web seems to be written in PHP, here's an example in PHP. You can see where my arrow is. You connect in up here with the standard host name, username, password. By the way, the new protocol listens on port 33060. Our standard protocol is 3306. But down here, we connect to a schema. And then once we get to a schema, we talk to a document collection. And from there, we issue our query. Now, you notice the query is not SQL, but it's still very easily read. So from that collection, we're going to find a document where the ID is equal to USA. We're going to grab the field's name, and we're going to call that country. Bring it the field geography and call that geo, and get the full key of geography.region and execute that. So no more embedded SQL. By the way, for those of you who have really good eyesight in the back, this is what a similar program looks like in JavaScript, Python, Node.js, C++ or C, and Java. Now, a side benefit of having this new, stronger API is that the calls between language look very, very, very similar. They should look almost exact. Sometimes you see an arrow operator instead of a dot operator. But the idea is that if someone in your shop, a new developer who's doing something in Python, and you don't know Python, but you're doing stuff in PHP or C++, you'd be able to look at their query and be able to help them. So, the new shell. New shell is also is no longer monochromatic. It has colors. And as you see, when you authenticate in, it tells you that you're speaking on the X protocol, the version, server of the version. And here I'm typing in session.create schema SCaLE. Boom. Suddenly I have a schema out there called SCaLE, and I tell the database I want to talk to that schema. Away we go. And then from that schema, I create a document collection called Pasadena with the command db.createCollection Pasadena. And then from there I type db.pasadena add, and I put in a JSON document. Now I didn't have to set up the relations, I didn't have to set up the indexes, I was just able to create the schema, create the document collection, and start saving data. Now if I want to find that information, I just type in db.pasadena.find. Now if you remember, let me go back, I put in two objects, the year 2019 and the name Dave, but the server put in an underscore ID. I'll get into detail on all that. That's how we track stuff. That's the NODB primary key for those of you who are DBAs. And let's say I want to modify that. So I type in db.pasadena.modify, and the record where the name is equal to Dave, and I'm setting a value called foo, or a key to the key named foo to value of bar. Do another find. There it is. So I was able to change my data structure without having to go through and do an alter table, add column, and wait for that to ripple through. By the way, if you look at the status of this, you'll notice some important changes. By default, MySQL 8 is UTF-8 MD4 all the way through. We know a lot of you are now dealing with things like foreign character sets or emojis, and we wanted to give you full support for that. Also, you'll notice that there's a line that says cipher in use, DHE RSA AES 128 SHA-256. We are forcing encryption on you. Your bosses are talking cloud, but they're buying encryption. We wanted to make sure that it was going to be very, very, very difficult for anyone to do a man-in-the-middle attack to actually be able to scrape your data as it's flying back and forth between the server. If you don't want to do that, there are ways to turn it off, but by default, we're forcing that on you. Now, a lot of us came back, the document store was evolved from people moving from MySQL to MongoDB and then coming back to us and saying, gee, I wish you had this feature where you can do stuff on the fly. So here's a quick example using the restaurants collection that Mongo uses in their documentation to show you how easy it is to move stuff from Mongo to MySQL. This is a command I lifted from Giuseppe Maxia, better known as Data Charmer, where he showed how to go out and have Mongo dump out all the information. Basically, it's going out and doing a find on that document collection, and he's actually grepping or purling out the Perl substituting out the object ID and the ISO date and creating a JSON file. And from there, in Python mode, where it goes from yellow to blue, he imports the JSON library, imports the regular expression library, opens up the file that he just dumped out, and reads it in line by line. This is 25,000 records, and if you run this, it takes about a minute or so. Not exactly fast. So our guys were looking at this and said, why don't we write a JSON bulk loader? So we now have a utility in the new shell. You type in util.importJSON, give it the file name, and any other parameters you want, and it loads into 25,000 records in just over 2 seconds. Very nice. Also, we've just added BSON support. We've had a lot of people asking for that, because there's a lot of interesting information out there that's in BSON that we didn't originally scrape together very well, but now you can go out and grab that. So. So, let's do an example query. If we type in restaurants.find, If I actually did this on the screen here, it would take a long time because I have an old, slow laptop and it doesn't take it too quickly. So if I did restaurants.find with a limit of 1, it will pull back the first record. Something to notice for later, these are restaurant grades in New York City. Do we have any New Yorkers here? Well, New Jersey doesn't count as New York. Like California, New York has restaurant codes where they rate the restaurants from A to Z or A to F. By the way, if you're in New York and you see a D or an E restaurant across the street, they might scarf you for the next entree. But you'll notice in here that we have an embedded array of grades, and that will come out a little bit later. So that's just one simple record that we have here. So this is the command you run to get that, restaurants.find, limit 1. Now, that's a lot of information. We didn't want all that. Let's say that we just wanted to get the fields of name and cuisine, and restaurants.find fields name cuisine limit 2. No SQL, or no structured query language involved in here. Now, this is a short comparison of the syntax between what Mongo does and what we do. I think theirs is a little more obtuse, and you have to pass it a JSON document, which, if you're in a hurry, is always hard to type. I think we're more logical. The same cuisine, same query, but I think ours is a little bit shorter and a little bit easier to read. Well, what happens if you want to remove a record? Well, here we say, okay, restaurants that remove cuisine equals French and borough not equal Manhattan, limit 2. It will go out and get rid of 2 records. So if you do the next find, it will come with 2 different ones than if you've run that just before. Part of our documentation is the railroad diagrams to show you what you can do with the various commands. If you're coming from an SQL background, these are going to seem very, very familiar. As I said, this is all on CRUD. So there's an add, modify. Notice modify, you can do array insertions or appends, you can unset values, you can delete arrays, you can patch stuff, you can sort, you can do limits, offsets, you can bind variables. So if you're iterating through some records and you're iterating something like a customer ID number or a zip code, you can do that. Remove is very simple. Once again, we have the binding option. Finding is a little more complex, but what you're used to from the SQL world is there. You have sort, having, group by, limits, offsets, binds, and of course, locks. So if you need to do transactions, you can do that without having to use SQL. Now here's the object summary. At the top, we have the database object where you're going to connect in and get a session. And from there, you can talk to a schema. By the way, a long time ago in MySQL, we kind of confounded the terms schema and database. The Postgres folks always hiss at me about that. We're still calling it a schema, and we probably should keep calling it a schema, although you'll hear me reference it as a database. But you'll notice the center box and the box off to the right. From the database object, you can talk to a document collection, or you can talk to a relational table. The only changes here is that when you talk to a relational table, instead of having add, find, modify, and remove, you're going to have the traditional insert, select, update, and delete. So let's start a transaction. And we have our transaction started, session.start transaction. And to a database or a collection called test, we're going to add a record with the name of VRene. And if we do a find on that with test.find, we have 2 records, Fred and VRene. And then we type a session rollback. That has the effect of wiping out that last insert. And then if we do the test again, we get just back to 1 record. The VRene is gone. Okay, Dave, this is really great, but I have a big investment, 20 some odd years of MySQL. I have a whole bunch of relational tables. I'm just not going to throw them all away. Well, you don't have to. Underneath the covers is the JSON data type that's been in there since MySQL 5.7.8. By default, all JSON information stored in UTF-8 and before, and there's like 27 functions right now for manipulating JSON data. Come over to the table and we can show you those. You can also take the data from the JSON and extract that and put it into its own materialized column. So you can do things like index that using the foreign key, and it gives you a lot of power. So once again, here's a picture of our architecture in 5.7, 5.8. On the far left, you see that you're coming in with either like MySQL shell or a Node application or a Windows application speaking the X protocol that talks to our X plugin that talks to the optimizer that does the storage. There's no actual mapping of stuff between the two because it's actually a new protocol talking to the optimizer. And on the right-hand side, you see our traditional protocol and model. Now, if you go into SQL mode on the new shell and type describe restaurant, the one we created a little bit on the fly, you'll see that there's that underscore ID field that's a var binary 32 that we store and generate, and also the JSON document that we very creatively called doc. Now, the ID has a lot of meanings if you're running an InnoDB cluster. Every document that gets inserted will have a unique identifier for that cluster. If you're just running on a single machine, it's going to have the same rough analogous value. If you don't assign an ID, the server will assign one. If you want to assign your own, you can, but make sure you're not duplicating numbers. Now, on the top, we have create collection, my collection. And that's in comparison to the standard SQL way of typing create table test, my column, have a document named JSON, set up the var car ID, then doing the generated always, extracting from the document the underscore ID field, and creating that as a primary key. Much less typing for the no SQL way. Adding records, much simpler. MyCollection.add test1234 versus insert into test doc values JSON object test 1, 2, 3, 4. Doing a find, finding records is much easier. So you do myCollection.find with key of test has a value greater than 100 versus select doc from test where JSON extract doc $test is greater than 100. So if you're a lazy typer like me, this will be a boon to us. So here's a way to do a generated column. We're actually going out to the restaurant's data and we're going to grab the key called borough and we're going to cast that as a varchar20 and create a column in the relational table called borough. And from there, it's like a regular, well, it is a regular column in a relational table that you can use all your SQL tricks on. You can also create indexes. Once again, we're creating an index. We're doing it on the field cuisine. We're calling it required. The only caveat in creating a required index is that if you try to put in a record that doesn't have that field in there, it will complain and kick it out. It doesn't have to be required, it can be optional. And if you look behind the scenes with the show create table, you can see how we actually generate all that. But the important thing is we can get the information. Now, without the index, we have to read through almost 25,000 records to get a restaurant that has Italian food in Brooklyn. Now, if we add the index, we only have to read 192 records to get that information. Big processing savings. Now, earlier when I mentioned that we had those embedded array of grades, each of these restaurant records has a series of one or more embedded arrays with the grades, the date, and the actual grade value. And as you can see in this one record, the first thing in the array is from March 2014, a grade A and a score of 2. and a couple other records. Here's one from September 2013. Now, we have the option of letting you grab the first grade, the array 0, or the last grade. And since we don't know how many numbers there are, we can just put in the keyword last. And you can also get a range, first to second, first to last minus 3. Gives you a whole bunch of different values. JSON table is a function that we have. A lot of the big relational databases like Oracle, SQL Server, MySQL that have added the JSON data type have added JSON table. What this lets you do is take this unstructured JSON document information, cast it temporarily as a structured table. Now, in this example, we're going to go out to our JSON column, once again, creatively called doc. We're going to read the entire document. That's what the dollar stands for. And what we're going to do is we're going to take anything that has the key of name, and any values in there will be cast as a car 40. And temporarily, we have an SQL table that we can do all the normal SQL tricks to get that information, to process that information. So you have a way to take this unstructured stuff and temporarily make it structured. Once again, this explains how the things map over. This is a bigger one where we're actually going out there and we're grabbing name, which you see over here, the address.street, and you see we cast that as a car 40, and so on. Now here's something you can't do with Mongo. This is something that we started being able to do with MySQL 8. In the red there, you have that JSON table. Whoops. Question? Oh, yes, sir.
So this, document store can also be joined with the relation database?
Yeah. The stuff that's in the NoSQL document store can be joined with relational data.
Right.
It's hard to see because your vest matches into the shirt, so you just kind of disappear. But the idea is we want to give you the most options possible. So if you have something that's in a JSON document and you want to keep it JSON, you can. If you want to pull out some of it with a generated column and have half JSON and half relational, you can do that. Or if you want fully relational, you can do that.
I thought that the new shell that make entry to the different engines.
Yeah.
Sort of kind of separate from the traditional relation database.
Yeah, the shell will let you talk either to the relational tables or the document collection.
Even though they have a separate,
You might be doing it via Python, you might be doing it via JavaScript, or you might be doing it via SQL. So we're trying to be like the Swiss Army knife of data processing for you.
And then the regular MySQL database has to be in the port, different port or is it port?
No, I probably should explain that. The new protocol has a plugin that's optional in 5.7 and turned on in default on MySQL 8. The new plugin listens at port 33060. The old one listens at 3306. So if you do upgrade to 8, you have to put an extra hole in your firewall if you have it firewalled off. And the server listens at both ports. And it wants to talk X protocol on the 33060. That talks to traditional protocol on 3306. Okay. So in red here we have the JSON table that lets you take the unstructured stuff and temporarily structure it. In blue we have windowing functions. These are high-end analytics that we just got in MySQL 8. Usually in traditional MySQL before 8, if you're doing analytics, you either did it on one row or all rows, or you had to do something nasty with a group by. With windowing functions, you define how you're partitioning the data. In this case, we're doing it by cuisine, but it could be by department number. It could be by last quarter to week previous, or any other way you can dice up your data. And once we have this temporary table from the unstructured data, and we arrange everything by rank, we feed that into a common table expression that we can use to basically do a very intelligent subqueries. Subqueries I've always found nasty to write, and I'm always having to look up what that error message means. CTEs are a way to write subqueries very easily. And if you come back at 4 o'clock, 3:30, you're going to miss that person. Gabriella is having a wonderful presentation about the new SQL additions, including CTEs and windowing functions. I saw this 2 weeks ago in London, and it's an excellent talk. Please be back for that. So, at the end of the day, documents build. What do I really gain? What's the net for me? Well, you get the best of both worlds in one product. You get the data integrity, the ACID compliance, transactions, and everything you want from a traditional SQL speaking database. You also get the ability to use it as a schemaless document store, where you have flexible data structures where your data is easily mutable, and it's easy to start coding right away. Mutable data has a lot of interesting properties. One of them, if you're doing a lot of nasty many-to-many joins, sometimes you can get rid of some of that stuff that you have to tunnel down and put that, what I used to call subtables, and put that up in a higher level record. So you don't have to hit the index and then hit the data, and then from there hit the index reference from that to hit the data, and then hit another index and another reference. Well, dives into the databases, into the index and the data. And plus you get to change things on the fly. Once again, you also have the ability to take your non-JSON data and turn it into JSON when you need to. Here's an example where we're using the JSON object function to take the string city and the column name and create that into a little table that's in JSON format that can be fed off to something else. Once again, you can use JSON table to change unstructured into structured data and then do all your SQL manipulations. In this case, we're looking for records where the independence year is greater than 1992. So, quick summary. MySQL 8's been out since April of last year. Big new features are a true data dictionary. The good news is you can now have millions of tables within a schema. The bad news is you can now have millions of tables within a schema. Once again, it's all UTF-8 MB4, so you folks who want to put your poop emoji in your data, we're supporting you. As I mentioned earlier, and Gabby will reiterate 330, windowing function CTEs, and just recently lateral derived joins. Big change there. Big changes in locking. We have instant add column. It used to be if you were adding a column to one of our tables, it was a major twiddle your thumbs while it took. We got a patch from someone in our community, and that's now instant. We have histograms, where if you don't want to add indexes and don't want to suffer the overhead of indexes on columns, you can use a histogram. Makes it a lot nicer. Resource groups. Those of you on multi-CPU boxes can actually dedicate certain CPUs to a certain class of query. So if you have CPUs 2 and 3 allocated off to a group called batch, you put a comment in your query that says resource group equals batch. It will be pushed over to those CPUs for processing. We have a much better optimizer with a new temporary table engine. We also have something called a CAT scheduler, which if you come to the booth we'll talk about. We also have three-dimensional GIS. With 5.7 you got Boost.Geometry's 2D world, and now we have a full ellipsoidal wraparound world. And also we have a bunch of JSON enhancements. And with that, the slides aren't up there, but they'll be up there later today at slideshare.net/DavidMStokes. 2 of my blogs are there. My Twitter handle is @Stoker, and there's my email address. I'm going to be over in the booth for the next couple days. There's a full range of talks in this room ending up at 5 o'clock or 4:30? 5:30 on security. So if you want to learn how to protect your data, so what's the title of your talk where you don't show up on the... What's the full title of your talk? How to avoid being on the front page with MySQL security. And with that, I have a few more dolphins here if you need one. We have a lot more at the booth, including plush dolphins and frisbees and stickers and all that. Have some handouts. What questions do you have? Yes, sir.
Can we, in the JSON document, can the ID field be something other than an integer or a number?
Yes, it can. You can have the ID force whatever you want. Yeah, if you want it to be a name or something like that, you can do that. But by default, we're going to use a varchar 32. Yes, sir.
Wouldn't it make more sense to use the NoSQL NoSQL document store versus having a bunch of JSON columns?
Won't it make more sense to start off with the document store instead of just having JSON columns? It's more dependent on your environment and your programming style, what you want to do. Unfortunately, the more and more I talk to programmers these days, they keep telling me they have bosses say, don't worry about what we're doing, just start coding now, we'll tell you what you're doing later.
Are there any performance degradations or any other?
Performance degradations I have not seen. I haven't got our benchmark guy to go through and do benchmarks. We have a wizard who lives outside of Paris who does amazing things with benchmarks, but I'm kind of low on the totem pole for getting requests on that. Yes, sir.
Does it support, the document store, does it support state MySQL replication? And what kind of storage?
Well, the great thing about the document store or the SQL side, the traditional stuff, that's a different layer of the server. The replication layer is untouched. We've made big improvements in 8.0. We'll have to show you at the table because we're going to run out of time. But the replication is totally different. So replication doesn't care. It's just happy to be able to slurp in the data and push it down the pipe. So replication isn't changing at all. So yeah. So if you're happy with your MySQL replication now and you start doing the document store, it's going to be the same thing. Just make sure you're making sure that that data gets replicated over. So if you have filters that only have certain schemas or certain tables going over, make sure you include the new collections. Yes, sir.
Is MySQL Workbench going to be updated to add the functionality for document stores?
Will document store be added to Workbench? Yes. For some sad reason, documents the Workbench seems to be lagging 1.5 versions behind. We're going to have another release in April. Hopefully, you'll see a lot more improvements with that. But you're not the only one who's noticing that we're not keeping up there. Yeah. Yes, sir.
Is there a containment operator to search through the arrays of documents?
Yeah, there are ways to search through arrays in the document store. Matter of fact, if you come to the table and ask me nicely and promise to do a good deed for someone, I'll give you a copy of my book which details how to do that. By the way, I wrote a book called MySQL and JSON, a practical programming guide. I should have had a slide up for there. If you're dealing with the JSON data type or want to, it's a little book available on Amazon, and it's mainly examples of how to use the various functions. And if that's it, I want to thank you all for coming out. If this is your first SCaLE, lots of good food across the street if you get stuck. By the way, don't go into the America's Got Talent thing. That is a horrible, horrible experience. I mean, having to stand up on front of the stage and sing for a couple hours. Okay. Well, thank you all for coming out, and have a good show.
Okay, can you hear me? I believe so. All right. Let me finish a couple things here, and then we will begin. All right, so my name is Alex, and this talk will be about deploying MySQL in Kubernetes. So for this conference, I would like to ask you guys, who have not using MySQL? Anyone who is not using MySQL here? Okay, excellent. And who is not using Kubernetes? Okay. So this is MySQL crowd, and you're probably looking to how to do things in Kubernetes. This is excellent. All right, so let's begin. My name is Alexander Rubin. I've been working with MySQL for probably too long. I have been started in 2006 as a MySQL consultant for MySQL AB, company behind MySQL, and been working for MySQL for some time until it was acquired by Sun Microsystems, and then MySQL was in turn acquired by Oracle. I joined Percona 2013, and just recently, it still says Percona, but just recently I joined a medical startup which is called Virtual Health. This presentation will be based on our work at Percona, and what we have been doing to deploy MySQL in Kubernetes. And they will be based on what kind of challenges we have been facing through the process and what we came to. So what is Kubernetes? Well, everyone knows that this is a container orchestration system, but in my mind, this is sort of operating system, right? So you use operating system to manage files, to run programs and stuff like that. And Kubernetes is a way to manage and run, obviously, containers, right? So how do you visualize the container orchestration? Is it like this? Well, there is a great visual, actually, for the real-world container orchestration. It's very easy. It's this. It's a seaport or ocean port. I made this picture in Barcelona. So this is I would say this is Kubernetes in real time. Seaport. So why do we want to use Kubernetes? Well, in deploying stuff, if you're running a massively scaled application, and I'm quite sure that many of you are doing that, if you are managing a massively scaled application with hundreds or thousands of servers, it's a big challenge to manage that, to deploy that and manage that. Or if you manage and need to deploy MySQL database as a sharded setup, who is actually responsible for MySQL sharded with at least 100 nodes here? Anyone? All right. So if you're running even 10 nodes of MySQL, it may be a challenge to monitor that, to deploy that, to scale that, and stuff like that. And this is exactly what we came from, right? So we have a request at Percona from a couple of our clients of how do we manage MySQL at scale. So Kubernetes implementation is cloud agnostic. And this is one of the things that our clients at Percona loved, about this. So there is a way to deploy it on-prem. For example, OpenShift from Red Hat for the commercial distribution, Kubernetes, the actual Kubernetes on-premises installation. There's also services that lots of people like to use in different clouds, Amazon, Container Service, Google, Engine, Azure, and others. So there are 35 public distribution of containers on the market, maybe more nowadays. So that means that you have no vendor lock-in to a specific cloud. So there's no lock-in to a specific cloud. You can manage that in different clouds. You can manage it in premises. One of our clients that we worked at Percona was actually saying that they don't want to go to the cloud, but they want to provision the database like it is a relational database as a service. So they want to provision database for their internal customers who they are considered to be their clients. And they want to click a button and provision MySQL. So that was our initial task. So let's look at under the hood. So when I started looking into Kubernetes, it was very simple, and it was like this. So a Kubernetes node, what is a node? It's a bare metal, a cloud server, which have a number of pods. Anyone who don't know what pod is? Everyone knows, right? So the pod is just for running the containers. A pod can contain one or many Docker containers. So we have this bare metal server, for example, or we have any other server, and we have a local storage. But now the whole idea of Kubernetes is to be able to provide the high availability, right? One of the things that it will provide. So we have multiple servers, all with a local storage. And then what will happen if one of the container will go down? Well, Kubernetes has the ability to move that container to another server. So it will shut down on one server, move it to another server. That's perfect. But there is a big issue with that, the storage. We have a local storage, and this architecture that was originally come up some years ago provides you a great way to deploy and manage stateless applications, like web servers or something like this. But it's not good for the databases. So again, container can be destroyed and restarted automatically. A pod can be destroyed and restarted on a different node. Pod can be multiplied, scale out. For example, if you need to handle more load, then you can scale out. Scale out meaning that you will create a new pod and stuff like that. So it's not very good for the databases because obviously we want to keep our data. So what are the challenges for the databases or any stateful set in container? First is preserve our state. The second is to have a way to replicate our data. So I would say there are two challenges, two major challenges, preserving state and set up a replication. So the new version of Kubernetes, and again, I'm talking about the history here, start supports stateful set. With a stateful set and persistent storage, databases became first-class citizens. How does it work? Well, very easy. We have a shared storage, and the shared storage can be allocated. A block of the shared storage can be allocated to each of the pod. And by turn, each of the container, Docker container inside of this pod can access that. So this picture basically demonstrates this much better. So we have a persistent volume. This is what has been in Kubernetes for a long time already. A persistent volume. A persistent volume is your shared storage, basically. And then each container, each pod, can request a persistent volume claim. a part of that persistent volume that will be available for that pod. So what that means is that as long as we have this shared storage available to all of the pods and all of the servers, if one pod, let's say MySQL here, will go down and will be restarted to another server, then it will reattach, will be able to reattach the same storage using the persistent volume claim and get our data back. So now let's talk about the MySQL specific challenges running MySQL in Kubernetes. Well, a single instance is very easy. Why not to just run MySQL in the container? That's it, right? But that's not how we usually work with databases. First of all, we need high availability. If one node will go down, the whole database should survive it, and our application should be able to reconnect. The persistent storage means that it will be quite a disaster if one node will go down and we will lose our data. That's unacceptable. And then we will need to have a backup and recovery. That's absolutely the necessity for databases. And then traffic routing, and I will talk more about that. So traffic routing is needed because we will need to connect our application to the cluster or high availability, highly available MySQL. And finally, we'll probably need to add monitoring to that. So this is the picture that we came up maybe 2 years ago already. This is what we want to set up. So we want to have a clustered MySQL replication, master slave replication MySQL. We will want to have the router, which will be using proxy SQL for that. And then we will use monitoring the PM server, which is open source, PM server for monitoring. And finally, there will be another volume that we'll use to do the backups. So we'll talk about 3 things here. I'll talk about replication, we'll talk about storage, and we'll talk about traffic routing. Those are essential things for managing MySQL in Kubernetes. So for the replication options, we have traditional MySQL replication, group replication, and Percona XtraDB cluster, probably. So we want to do a very simple thing, right? So we want to replicate our data from one MySQL to another MySQL. So traditional MySQL has some challenges, especially when we go to Kubernetes. To me, the most challenging part of the traditional MySQL replication is no automatic failover. So if you have a master-slave replication, there's been tons of scripts and tons of tools how to fail over from master to the slave. Now imagine we are going with Kubernetes. What do? We need to take those tools, open source tools, and put them on top of that. Right? That's possible, but it's not very easy. The master detection can be also complicated. And the second big challenge is there's no automatic slave setup. I know this is MySQL crowd, this is great. So who in this room never set up MySQL replication? Anyone? Okay, 3 people. So for those 3 people, I can tell you this can be challenging. So it is very straightforward though. But there are a number of steps that you will need to do. You will need to do a backup. You will need to copy this backup. You will need to record the position, the master server position, and master binary log. And then finally, you need to do change master to. It's very straightforward. There are lots of tools that automate that. But again, we will need to bring that into Kubernetes to set it up. Group replication is another option, but it's a new option in MySQL. It's available in 5.7 and 8, but there's still no automatic slave setup. So for the purposes of this presentation and for the work that we have been doing at Percona, we have decided to use Percona X3DB cluster as our first attempt to move MySQL in Kubernetes. Why is that? So Percona X3DB cluster provides it's based on Galera cluster. It's open source. So it provides the group replication between all three nodes. So it's a synchronous replication, unlike MySQL replication, or I would rather say, to be 100% correct, I would say it's semi-synchronous replication. What that means is that your application that will write to node 1 will have to wait until this change will go to node 2 and node 3. But at the same time, it will give you much higher consistency level. So if something happens with our node 1, then you can still use node 2 and node 3. The data is already there. The second big thing about PXE in Kubernetes is that PXE supports auto provisioning. Unlike master-slave replication, where we need to perform all those steps to set up a slave, you just join the node, the blank node, to PXE cluster, and it will automatically join. What will happen under the hood is that this node, which has no data, will connect to the cluster, will request the backup, and the backup will be sent over automatically, and then the node will join. So the ability to automatically join a node is a great thing, especially for Kubernetes. PXE supports basically two modes of data transfer. The full data transfer, which is called SST, and when the new node comes in, it will make the backup, and then everything will work. IST is incremental transfer. So if the node is offline for maybe 5 minutes, 10 minutes, I don't know, for the short period of time, it will be able to request the changes only. All the changes are being accumulated on the node, and then it can request a change and join the cluster this way without requesting the full backup. All right, enough for MySQL cluster part. Now storage. Well, storage is actually, I was expected when I started this project at Percona, I expected that the storage will be hard to do, but eventually the storage was not that big of a deal. So for the storage options, we have local storage, which can be fast, SSD and NVMe, but it has a limited set of capabilities in Kubernetes. And then we have a network storage. With a network storage, we can use the volume claim and persistent volumes, and that works very well. Performance of that is a debatable part. But from the management standpoint and from the provisioning standpoint, that is pretty good. Kubernetes also, if you are in cloud, Kubernetes supports the way to request the block devices natively from AWS or from Google Cloud, for example. In AWS, you can do EBS as your volume, persistent volume, and then it will support requesting the new block device for the specific volume. So finally, traffic routing. Why the traffic routing is important? Well, if you have one node, one instance, then you simply configure your application to connect it to that instance. If you have 3 instances or more, you need a way to connect to the cluster and not to one node out of this cluster, or at least have the ability to reconnect in case of failover. So for traffic routing, we're using Proxy SCaLE, an open source high-performance MySQL proxy. So Proxy SCaLE supports the query routing and supports failover. And I will show you in the next slides how it performs all these tasks. But first of all, what is Proxy SCaLE? Proxy SCaLE is basically man in the middle. It's another service that sits on top of the MySQL cluster or master slave replication or something. And your application will connect to proxy SCaLE. So here on this picture, right? Normally we will connect MySQL, we will connect our application directly to the master. Instead of that, we are introducing this proxy SCaLE, and the application will connect to proxy SCaLE, and they will forward our request. This is very helpful in Kubernetes. Proxy SCaLE also supports read-write split. So read-write split is a way to handle the traffic. Your application may have been not aware of MySQL replication at all. Proxy SCaLE supports traffic routing by analyzing the query text. So you connect your application is doing some transactional stuff, some selects, some writes, some reads, and then proxy SCaLE will read that, analyze that, and depends upon what it is, it will send it to a specific node. In this picture, we have a Percona X3DB cluster, 3 nodes, but it can be anything. Yes, go ahead.
Some transactions take 5 to 10 minutes. The cluster stop the reads?
The transactions are 5 to 10 minutes. The cluster will not start the reads. Stop the reads?
For consistency.
Well, this is something that we can probably discuss additionally. What you're talking about is a specific limitation, I would say, of the Percona X3DB cluster. That's a very good point. However, I think that this is sort of outside of this discussion. I will be happy to talk later on about that, but this is a good point. So let's say that we have 3 nodes of PXE, Percona X3DB cluster, but at the same time, it could have been MySQL replication as well. So for the proxy SCaLE will be, on this picture, proxy SCaLE resides on each application server. So we have actually 3 proxy SCaLEs. And each proxy SCaLE is responsible for sending the traffic over to the specific nodes. So if it's write, then it will go to the writer. Then if it's read, it will go to the reader. So the application will connect to proxy SCaLE. Proxy SCaLE will handle the traffic. And I will show you later on why this is important for Kubernetes. Yes?
How does that scale, or how does health check work in that state? As you scale applications to multi-thousands of applications all responding to MySQL queries or trying to do MySQL queries, just your health checks from your proxy SQL, how does the load go for that?
Right, and this is a very good point. If you scale, so the question is, if you scale to hundreds of application servers, each application server will have its own proxy SCaLE. Will this health check will kill MySQL? That was the question, right?
Yeah.
Definitely. Oh yeah, it will, if you're talking about thousands or 10,000s of application servers, each running proxy SCaLE, the health checks can definitely kill MySQL. So for that, we will probably need to run different architecture, and we will probably need to have something proxy SCaLE here in the middle and 2 proxy SCaLEs. Yes?
What is the ratio of writers to readers?
So the question is, what's the ratio writers to readers? So in the Percona X3DB cluster, we are talking about 3 nodes, usually 3 nodes. 1 writer, and all nodes can be readers. So in this case, we have 1 writer and 2 readers, or we can have the writer be the reader as well. Yes?
What do you mean about the main from server running on the server? Is it same pod or different pod or different?
Right. I will talk about that on the next slides, how we actually deploy that. So the question is, will the node will be in its own pod or collocate. We definitely will need to have one node to be in its own pod, because the whole idea of failover and moving and migrating pods as well will be much easier if we will not collocate. And also for high availability perspective, we will need to have 3 nodes. That's the requirements of PFC. We'll need to have 3 nodes, and 3 nodes needs to communicate with each other. All right, so now finally let's talk about the Kubernetes implementation part. This is what we want to do. We want to have a MySQL Percona X3B cluster and proxy SQL and application server on top of Kubernetes. Anyone done that? No, okay, good. So we will try to do this. So final part is the Percona Monitoring and Management Platform, PMM. That's MySQL monitoring. It's open source. It's free of charge, of course. And then you can also, we will be trying to integrate that as a part of our setup as well. So now let's talk about deployment options. How do we deploy? And again, I will talk about a little bit history here, how we approach that and what we came to. So first of all, this is our picture again. This is the original Percona OpenShift, Percona Lab, Percona OpenShift repository that we have came up. This is not production, that was for our testing. And then we have started this as a manual deployment. So even nowadays, we have 3 ways how we deploy anything, in our case, MySQL. We can use manual, we can use Helm charts, which came later, and then we can use operator, which is probably the easiest and the most robust way to deploy MySQL in Kubernetes. So this is how I started this project. I wanted to see if this is possible. And then we came up with a number of YAML files and quickly realized that this is not easy and this is cumbersome. So we have to create, so how do we create? We have a YAML file, right? And then we need to provision the resource with YAML file. So what we do is kubecontrol or OC create and specify the YAML file. But on top of that, if we have multiple YAML files, we will need to provision them in a specific order. First of all, I need to request the volumes. Second, I need to create MySQL user password. So this is secret YAML file. Then I will need to create a my.cnf and provision the config map. Config map is a way to store some parameters. I'm using config map. We're using config map here to store my.cnf, MySQL configuration variables. Then finally, we'll need to provision PXE. We'll need to provision proxy SQL, and then we'll need to set up the monitoring agent. So I was like, well, I need a bash script for that, right, to provision that. So we're talking about Kubernetes, and now I need a bash script. So that's hilarious. So now Helm came up, and that was a great help. Helm is a sort of package manager. If we're talking about Kubernetes being operating system, then in my mind, Helm is something like a package manager, like RPMs or dev packages. So that was a great help because it will allow to separate configuration from logic. Helm has the templates, and the templates will allow you to do something like, well, we need to specify these parameters here, and there are some if then else cases in this. So Helm provides the templates, and with the Helm we can just do Helm install and specify the values file, which will have all our configuration variables, all our customization for our implementation of MySQL. And then finally, the operator came in, And operator is actually much better than Helm as well. Well, operator is also the day-to-day management. It's not only the deployment, but it will provide you with the ability to manage a MySQL. If you need to do a backup, if you need to scale, you can even do some auto-scaling stuff if needed. So this is basically the original picture that we looked at, how the operator will work, right? So the installation upgrades, which is good actually. I think I love the idea of being able to automatically upgrade stuff, right? Because especially with a 3 nodes cluster, we need to upgrade it node by node. Some lifecycle management, and then finally some insights and autopilot. So now I will do a very quick demo of installing basically how it is done with a Helm chart. I have recorded the demo, so there will be no hands-on demo. I had a very bad experience doing demos with with flow connection and stuff like that. So this is something that we did for the installation of the Helm. That was sort of intermediate step when we were coming from YAML file management to the Helm and then to operator. So with the Helm, you specify the name of your cluster and then you specify values. Inside of the values, you just customize whatever names you have, whatever passwords you have, whatever parameters you need to pass to MyDSNF. So with this single command, what will happen is that it will start 3 nodes of PeerConnect 3DB cluster. It will configure the PeerConnect 3DB cluster. It will configure proxy SQL. So let's imagine that we started it, and then we run get pods. So now we can see that this node 0, 1, 2 running, proxy SQL running, and monitoring agent is running as well. So let's take a minute here. What has happened? With a single command, we have started multiple MySQL nodes, provisioned them, so they form the cluster. Kubernetes now handle the node failure. If we have a failure of one MySQL instance inside of the container, or the whole pod will go down, then Kubernetes will restart it. If there will be a problem with storage, for example, Kubernetes will be able to restart it on a different node. It also started and configured proxy SQL. So it did some basic discovery. So proxy SQL discovered our nodes and automatically configured that. And then finally, we added the nodes on the PMM server, PMM monitoring. So there's a PMM agent will collect some information about the MySQL, about the nodes system as well, and then send it to PMM server. Now, which one is which? So we have the cluster proxy SQL, that's our proxy SQL, and then we have 3 nodes. But now the main question that we need to answer, and probably the developers will ask that question, how do we connect our application to this? Well, we connect it to normal port 306, but we don't connect to any specific MySQL nodes. We connect it to proxy SQL. We connect it to cluster IP, which is provided by the proxy SQL running on top of the Kubernetes. So cluster IP will be exposed, and ports will be exposed as well. So you connect your application to port 306, and then proxy SQL will use the admin port that you can use to check the configuration. It's probably a bad idea to reconfigure proxy SQL in this setup, because this is what our Kubernetes setup will configure it. But we can still see what's in there. So what I'm doing here is I connected to a container, proxy SCaLE container. The reason I'm connecting to the container is that by default, all this authentication only available from the local host. We can change that if needed. But what I'm doing is I'm connecting to the proxy SCaLE pod, proxy SCaLE container, and connect to this port. And then proxy SCaLE has a way to configure. And when we deploy MySQL, we deploy the whole thing, we will auto-configure proxy SCaLE. And this is how we have auto-configured. So we can see that one node is our writer, and two other nodes are readers. When we send the traffic to MySQL, then it will process all the traffic, and depends upon what it is, it will determine will it go to writer or reader. So what do we do next? The next thing we will do is we'll break things. So we will kill one pod. So we can, in this case, we can either kill it gracefully, we can shut it down, or we can just kill -9. It doesn't really matter. What will happen is that Kubernetes will restart it. If we kill the pod, Kubernetes will restart it. Now, how does the proxy SCaLE will react to that? Well, proxy SCaLE will be able to determine that this node is down, and then it will choose one other node, one reader node, and promote it to be the writer. When the node will come back, then we'll put it back to the pool as a reader now. So that is the good thing for Kubernetes to handle that. Have a question? Right, so right. That's a very good question. In the proxy SCaLE configuration, you can list the servers, so they will be deterministic. So there's like an order of the servers. In this case, proxy SCaLE will always choose the next one from the list. So then the decision will be, they will be consistent across the nodes. Yes?
in your cluster, and now that proxy SQL is upgraded one of the readers to a writer, while the other proxy SQL instances all have a different writer.
Right. So that's definitely can happen. That's probably some worst case scenario. But even in this case, what will happen is that it's not recommended to write to all 3 nodes in our PXE cluster, but it is possible. You can still write to 2 nodes. And the worst case scenario here is conflicts. And the conflict presents itself inside of as well, be lower or higher, and then you can choose which host will be preferred to that. That's right. That's a good point. All right, so the next thing that we will do is we'll try to scale it up. Well, in a cluster, actually, in PXE cluster, we don't want to have an even number of nodes. That's for the quorum and split brain prevention purposes, right? But in this case, I am just doing it regardless. So, so I'm doing it for the test purposes and created 4 replicas. Don't do that in production, right? That's not safe. So now I'm doing this. I do scale, and here we go. So I look at the servers. Then I have now I have 4 online nodes and old offline node being stuck here. It doesn't matter if it's offline. Proxy SCaLE will not choose it. So with this, so scaling up, scaling down works pretty well as well. And proxy, and you don't need to do anything. When you come up, when a new node will come up, That was the big advantage of doing that in Kubernetes that way, because when a new node will come up, it will have no data. It will automatically join the cluster. The cluster will send the data over by doing a backup from one of other nodes, from the donor node. And then proxy SCaLE will register that. It will detect that the new node came up and then register it and then will include it into the list. So now I will do a quick failover demo. Let's see if it will work here. All right, let's see if I can pause. All right, so what I'm doing here, I want to simulate an application. But when you connect to MySQL through the proxy SCaLE, you cannot even understand, cannot even know if it's writer or reader, unless you use this variable called hostname. So this is not the best script in the world, but it do its job. So what I'm doing this is here is that I'm selecting the hostname, and when I doing a select, then I assume that there will be a reader. When I doing it select for update, I assume that it will be. Unfortunately, the screen doesn't show much. But what the trick that I'm doing is this. I'm configuring the proxy SCaLE to handle select differently from select for update. Select for update is a specific clause that will probably means that you will be writing immediately after that. So I'm configuring proxy SCaLE. Select will go to readers. Everything else will go to the writers. And select for update will also go to the writer. So in this case, I can determine in a script if there will be a reader or writer. If I'm sending select, then I will go into a reader, if everything works, right? So now I run the script, and then I basically show that this is reader, this is writer, and they are reachable. All right? So now what I will do is I will kill the node. So I found this cluster node 0, which is our writer, and then I will just do this. I'll kill the node. And then what happens is that it will hang for some time when the proxy SCaLE will determine that this is a failed host. And then here I can see that the host is, let's pause for a second. The host is still showing running, but it's not ready yet. So MySQL is not reachable in this case, and the proxy SQL will choose another host and re-provision the service. And then I started to do, I was very impatient, and I didn't want to wait. And so then I was thinking, well, maybe there's something wrong here, right? So I ran this command, oc get logs, or kubecontrol get logs, and then it will show me the MySQL error log. And the MySQL error log now says it's running. And then everything is back. So the proxy SQL have reconfigured and then get it back. All right, so that was a quick demo for how it worked when we did the Helm chart. So now I don't have a demo for operator yet, but it's very straightforward. We have came up with a Percona X3DB cluster operator and MongoDB operator as well. So there's a very good documentation here on the website, on the GitHub website. And you can run now the operator. I have also created, if you guys are interested in playing with Kubernetes and you don't want to basically do it on your own machine, you can go here and there is a set of scripts. This is based on Vagrant that you can provision the small node in either virtual on any cloud. Basically, you can use AWS, you can use Azure, you can use Google, or it can use the VirtualBox on your machine. It will provision the Kubernetes Minikube that you can basically play with. And then there will be some exercises, some list of exercises that you can go through to install anything. Other resources include, there's an Oracle MySQL operator as well. There's a PressLab operator that, the PressLab is a company that managed, WordPress. And there's a MariaDB Helm. And there probably, nowadays, there are probably many other projects that are implementing MySQL in Kubernetes in any way. So the conclusion is that OpenShift or Kubernetes, doesn't matter, provides easy deployment for MySQL. In our case, we have played with the Percona FTP cluster. And Proxy SCaLE, I love Proxy SCaLE because it will provide the way to connect your application directly to the cluster and using the traffic manager to handle the failovers and handle the scaling out. I think that's all. I'm open to questions. Thank you. Yes?
Thank you. Forgive me if I end up missing this, but you mentioned that you're picking up the mounts with your actual data from a remote storage. Are you actually mounting that remote storage live, or are you just copying it into the container on the front end?
Oh, I see. This is done by, so the question is how the cluster gets the data, right? Synchronize the data. So the cluster doesn't use any, raw data copy. It doesn't use the blocks. It will request a backup, and the backup is being copied to the container. So it's a MySQL. It's basically MySQL backup. It's a MySQL file. So it will not.
So it's still serving some local disk in the pod container. It's just not. All right.
Right. It depends upon what you're using for that, right? So you can use this shared storage. It doesn't matter. It just copy the file.
Great. Thank you.
Sure. Yes.
In the situation where you need to shut down your whole Kubernetes,
Uh-huh.
and the state is really preserved in a backup, how do you reconcile the difference in data between the last backup and the last one?
Uh-huh.
So you're starting from scratch, but you had a database name prior.
Right. So if you have a backup and you want to restore from the backup, right? But you want to see what is currently on inside of the volume, right? But your database is not running, right? Am I getting it right? Right. 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 So you can still reconcile and see what is inside of your backup. You can mount the volume directly to another pod and see what is in there. Or the backup volume, you can do the same thing. And there will be files there from MySQL. There will be files there from, backup. If you shut down the whole cluster, then right, but your data is still there. The data is on the shared storage, right? So when you start the cluster again back, then we'll pick up the data.
So does it load from backup? It just picks up.
Exactly, right. Well, from the shared storage in this case.
Sure.
Mhm. Mhm. Yes.
Can you talk for a second about performance
Ah.
performance and backend storage and preferences, best practices that you've discovered? Ceph is not necessarily known for the
Right.
latency.
Right. So the best, what we saw is if you're using AWS, for example, I would do EBS volume there. If you're using the SAN on premises, then you can use iSCSI. So those are probably two most performant options. For on-premises iSCSI, which will directly connect to your SAN, or if you're in cloud, then use the block device.
How much worse is Ceph?
That I cannot answer. My colleague was looking into Ceph, but I have not looked into Ceph. NFS is horrible. NFS mounts are horrible, but Ceph I have not seen that. Yes.
With iSCSI, do you have any issues with data corruption or things where it's a line migration of a pod between nodes, or if you have a situation where you're migrating data between the Pasadena locally and the iSCSI?
I have not seen that. I heard that maybe such issues. My understanding is that if you do iSCSI, you have multipath, you have some locking there. So you're talking about corruption, like two nodes will start writing to the same block?
I don't know if it's a special case or whatever, but I've had some issues
Uh-huh.
sometimes with file line migration.
Uh-huh.
And you're moving a pod from one place to one node to another, and it's like the disconnection.
Right.
Particularly if you have multiple volumes or something that is attached to the actual pod itself. MySQL, you can get a memory state and corruption issue into it. It won't show up for 46 hours.
Wow. I have not seen that, and probably need to look into on which level, on what level this is done. Is it on MySQL level? Is it corruption on the disk, or is it
It's in the MySQL level.
MySQL level?
It's in the MySQL storage. It's not, there's no disk errors or anything.
It's not disk errors, right?
No disk errors or anything else.
Right. So it's InnoDB. It's MySQL InnoDB corruption, probably, right? Yeah. Yeah. So I mean, that's possible. I mean, it's not very common scenario, but that's very hard to diagnose. So.
It's in 5.6.
Ah, okay. Right. Mm-hmm. Right. Mm-hmm. I see. It may or may not be related to the whole iSCSI stuff. Yes. Oh, the slides? Yeah. I don't know what SCaLE is doing for the slides, but I will upload them.
I'm having trouble seeing what Kubernetes is buying you
Uh-huh.
versus just having multi-instances on a single host.
Right. I have heard about a lot of that comments, right? So this is valid. This is valid. What Kubernetes is buying us if we will use MySQL in Kubernetes, right? I think I think the main advantage of Kubernetes is first easy deployment, much more easy deployment, right? You can still do that with Ansible, of course, or with any other deployment option. But the second part of that ease of deployment is that you can run it anywhere. So, for example, if you are going to AWS and then will decide to migrate to another cloud, or if you are in premises and then you want to migrate to AWS, that's a huge project to move all the infrastructure, including MySQL, from on-premises to AWS. We are actually at that position at Virtual House right now. We are migrating whatever we have in our data center to AWS. And then in the future, if we will need to migrate it to somewhere else, There will be another project. And with Kubernetes, it's just copy and start. That's fun thing.
Thank you.
Sure. Yes.
May I add you on LinkedIn?
Oh yeah, of course, of course. Good. That's why I'm putting it here.
I just thought we'd like
yeah, yeah.
Is Persona hiring?
It does. I'm not anymore with the corner, but I can talk to Peter about this. Definitely.
Oh, here's my card.
Uh-huh. Cool. Very cool. Thank you. Thank you.
I have a question.
Yes.
A question about, I would like to know your opinion on operators.
Uh-huh.
The operators. You know, there's yours, there's also the Oracle one, there's also the press button.
Check. 1, 2. I think it works.
I was one of the S's. The long face S's.
Yeah, it's not bad. Lovely. All right, show of hands. Who's used MySQL before? That's about what I would expect, I think. Yep. All right, what about GTIDs?
What?
GTIDs. A few people know what that is. That's good. Yeah. All right. What about binlog server of any kind? A few people. Sweet. All right. This should be fun. I think that I might get an introduction, but I haven't seen anyone yet, so I'm just going to introduce myself. So, all right. Welcome, everyone. Good afternoon. Thank you for coming. My name is Sam Dunster. I'm a production engineer at Facebook. I've spent a bit of time working on MySQL. Throughout the talk, just put your hand up if you've got any questions. I expect this to be a little bit interactive. Cool. Yeah, just put your hand up. I'll try to remember to repeat the questions. Remind me if I forget. So let's start with a little bit about me. I started building LAMP stacks in high school. I used MySQL for a few different projects, but I've never really been that much of an expert. I don't really see myself as a DBA. In fact, you could even say, you know, this stuff doesn't really excite me that much. But what does is SCaLE. I joined Facebook about 4 years ago, and I was looking for a team that works on big distributed systems. And it turns out MySQL at Facebook is one of those. It's huge, and we manage it all using a bunch of Python automation. And that's the stuff that gets me really excited, especially when we're talking about different edge cases. So the topic for today is consistency. We do things at Facebook a little differently in order to achieve what we think is the ideal intersection of consistency and performance. I'd like to today tell you about the story of how our solution came about and the tweaks that we've done to it along the way. So before we begin, let's start by talking about replication. So MySQL replication is pretty flexible. You can use it for a number of different reasons. One is performance, right? You just want to reduce the load, spread it across different instances, especially a read load. The other one that I think is more important is for high availability. So this is why we use it at Facebook primarily. And we're interested in making sure that our replica sets and the important data on them is readable and writable for the maximum amount of time. So that's why we use replication. Most services at Facebook have one instance per region, right? We'll put the master in one region and we'll put the replicas in different regions. Sometimes one of the replicas will be in the same region. Note that we don't use master-master or group replication. So the replica that's in the same region, we might see 10 milliseconds of latency over the network between the master and the replica. But because we're globally replicating across many different regions around the world, sometimes these jump up to as much as 250 milliseconds, for example. This becomes pretty important as we evaluate the different types of replication that are available to us. So the first one that most people have probably used is the default in MySQL, asynchronous replication. Let me show you how that works. So if we have a master and a single replica, just for this diagram's purposes, normally you would have more than one replica. The master is going to have a storage engine. It could be InnoDB, or if you don't care about your data, you might use MyISAM. RocksDB is another option that Facebook uses. There's a few different ones out there. The important thing, though, is the storage engine is storing your data, right? And it provides all of those, the fancy features that we expect from a real relational database, like indexes, right? So the data is, the canonical set of data is stored in that storage engine, and we also keep a log of every transaction that's been made on that instance, every write. The binary logs store all of those transactions. They do it in a binary format, mostly just for efficiency purposes. The replica also has both of these things. So let's run through a scenario now. If a user wants to make a write, such as this one, it'll go off to the master. The master will go and check the commit, make sure everything's good. It'll go and write that into the storage engine and the binary logs. And at that point, we can return back to the client and say, the transaction's good. We've got it. You're okay to proceed with the other logic that you need to do. Note that the replica hasn't seen the transaction yet, right? And this is where the asynchronous part of replication comes in. So once the transaction's available in the binary logs and after we've returned OK to the client, we then, the relay logs on the replica will get filled from the binary logs on the master. And the thing responsible for this is the slave IO thread. So it's constantly trying to keep the binary logs, the relay logs on the replica up to date with the binary logs on the master. Note, however, that it's not actually committing those changes into the storage engine or the binary logs. And also note that because of network conditions that we were talking about before, sometimes this can be delayed, especially if the slave IO thread is copying large amounts of big writes. Those transactions can take a while to transfer over the network, and this can cause replication lag. So the other component that runs on the replica to keep this stuff up to date is the SQL apply thread. So it's constantly checking the relay logs, and every time it sees a new transaction, it'll take that and apply that to the storage engine and the binary logs on the replica. This too can also introduce lag. If the transaction that we're trying to make takes a long time to apply to that storage engine, then it will start to lag as well. But that's completely independent from the IO thread we were talking about before. So just as a reminder, the master is read-write. If you want to make writes, you have to go to the master. And the reads, if you send them to the replica, might be delayed in the sense that the replica isn't guaranteed to be up to date with the most recent transactions. Cool. Any questions at this point? Awesome. All right, so let's dive a little more into the binary logs. Turns out there's a few different ways that we can store and work with these. The first one is position-based. So the way that we keep track of which transaction we're up to in a binary log is we have the file name of the binary log we're up to and the position, which is the offset of the number of transactions into that file. This works okay as long as the files line up. The binary log on the master must match the binary log on all of the replicas, otherwise positions wouldn't line up. Note that this is kind of a problem because there's no easy way to identify which transaction you're across unless these are in sync, and it can be really hard to detect whether you've got an extra or missing transaction on any given instance. So the way that we can fix this with MySQL is by using GTIDs. GTIDs are assign a global transaction ID to every single write that comes into the server. So the way that we do this is a transaction ID basically has two parts. It has the source ID, which is the UUID of the instance that's committed a transaction first. Usually this is the master. And an incrementing integer that represents that individual write. So this is a GTID, but we can also combine these together to form GTID sets. And this is really useful for answering this question. If you want to go to an instance and say, which transactions have you executed, it can return to you the complete list in the form of a GTID set. In this case, we have 3 transactions that have been committed on one instance. Then there was probably some sort of master promotion or something, and 19 transactions committed from a different master instance. This has a nice property as well, because of the way GTID sets work. It's very easy to do auto positioning. So if you have a replica that you want to point to a new master instance, you can simply run the change master to command with master auto position equals 1, and that instance will negotiate with that master to make sure that it has all of the transactions that master has, especially as more and more are coming in. So GTIDs are pretty great. Facebook totally recommends that everyone uses these as early as possible. If you are using GTIDs right from the start, you don't have to do a migration. It will save you a huge amount of pain in the long run. And even if you're not using GTIDs today, the migration to it isn't that painful, and it's totally worth it for the dividends it pays in the long run.
Is it thoroughly documented somewhere how to do a migration?
Yes. The question is GTID migration thoroughly documented? Yes, there is a section in the MySQL documentation that will tell you how to do it. I don't know if I can call it thoroughly, but it'll run you through it, and there's plenty of different war stories and other stuff out there from different people doing it. Yeah. All right, so if we jump back to that diagram I had before, and we pull back to just where the transactions have been committed on the master, and we've sent an acknowledgement back to the client. The transaction hasn't been replicated to the replica yet, though. And imagine a scenario where the master then dies for some reason. In this situation, we have data loss because we've acknowledged the transaction as being committed to the client, and we've written that to a server, but it's only been written to one server. And so if we lose that server, we now have a lost transaction, right? That the client assumes we're going to keep safe. So we need to look into different ways of fixing this problem. The way we can attempt to get ourselves out of trouble in these situations is with promotions. There's two different scenarios that we need to be able to deal with. The first one is a live master promotion. And this can be great for proactively shifting load, right? If one instance is really busy, we can shift it across to a different instance, make it the master. It can also be good if we can detect an impending problem with an instance, right? Maybe a flash card is about to die or something like this. We can go and do that promotion away from it and then take that instance out of service, do a repair or whatever we need to do. And the real nice thing about a live master promotion is we can do this with a minimal amount of downtime. We do need to be able to deal with the situation where hardware dies unexpectedly, though, for the reasons that we were talking about before. And so in these situations, we want to do a dead master promotion. We can do these in response to a failure. So let's look at how these work with asynchronous replication. So in this case, the red arrows kind of represent writes coming into the master, and they're being replicated asynchronously across to the replica. The first step of doing a live master promotion is going to be to stop those writes coming in. We can do this via a service discovery system. We can do it with a config file. It really depends on your situation. So we stop these writes coming in. We have to wait for the existing queries to finish. Maybe we kill long-running ones. If there's something that's been running there for a while, it's better to just kill it and return an error back to the client than it is for it to accidentally land later on and result in a phantom write. So once that's done, we can jump on the replica and run master pos wait. This will block until that replica has caught up to all of the transactions that are on the master. Once this is done, we can then shift the roles around. So we can make the replica read-write, and we can hook up that old master to the replica by using the change master command. So now we've reversed the roles. The replica is now a master, and the master is now a replica. We can start taking writes again at this point. All right, so what about a dead master promotion? So this is the same kind of diagram, but imagine we've got an orange transaction here that's just come in, and it hasn't yet had a chance to move from that master to the replica. And this can happen at any time, right, because hardware failures aren't predictable. So if this happens and we lose that master, that orange transaction now is going to be stranded. So what we can do, there's a few different things that we can do to try and make this better. We can wait for the SQL thread to catch up to the IO thread on the replica, because the replica might have copied some transactions off from the master that it hasn't yet applied. If we might get lucky, and that most recent transaction then gets applied on the replica, but there's no real way for us to know. The other thing we can do is we can go and check all of our replicas, because we probably have more than one, and we can find the one that is most up to date, and make that the master, because we can then, that reduces the chance of data loss, right? But at the end of the day, we can ultimately never really tell whether there's a transaction that's been left behind on that original master or not. So we need to look into some different options. So the next thing that we can look at is synchronous replication. This is kind of at the other end of the scale of asynchronous replication. There's lots of great things out there that do this, like Galera or MySQL's new group replication feature. Basically, you're looking for anything that uses a consensus algorithm like Raft or Paxos. So let's look into this. Synchronous replication works, so a transaction comes into the master. You can assume that there's more than 2 instances here, by the way, because you can't really form a quorum. And so this transaction will then be written across to the other instances. The other instances must acknowledge that they've committed that transaction locally before the original master can then finally send that commit, that acknowledgement back to the client. So all instances basically act in lockstep. They all get updated at the same time. And keep in mind, this is a massive oversimplification. Raft and Paxos are very complicated protocols, and you can read into how they look, how they work. So how does a live master promotion work with synchronous replication? Because the acknowledgement process, the quorum that's formed, just kind of works, we don't really need to worry too much about the details. As transactions come in and we want to shift them to somewhere else, we can just slowly shift that load to a different instance, because effectively everything in the replica set is a master. So if you imagine now a dead master promotion, this time we have 3 instances. If the transactions are all coming into one that we're designating the master, even though really anything can take transactions, a dead master promotion where we lose that master is as simple as just rerouting that traffic using the service discovery mechanism we were talking about before. So note that with synchronous replication, though, we need to have at least 3 instances at all times to maintain a quorum. We can act with 2, so if we lose one, we're still okay. But if we lost a second one at that point, we wouldn't be able to form a quorum and we wouldn't be able to make writes. So you need at least 3, and this comes with a pretty high performance penalty as well, especially if you move these instances across the globe, right? Because every single instance needs to, well, the master that takes a write needs to talk to every single other instance and get an acknowledgement before it can write that back to the client. If you have stuff spread around the globe, these transactions start to take a very long time to make. So we need to try and look for something that is around the middle. Oh, one more thing I want to say is that the other alternative here is we can put all of these instances in the same region and not spread them globally, but then we lose our redundancy. And in addition, you need to store 3 complete copies of the data in that region, which is something that we want to try and avoid. So let's look for something in the middle, semi-synchronous replication. So the way semi-synchronous replication works is a commit on the master triggers a wait on a replica acknowledgement, just like with synchronous replication. The difference here, though, is that we only need to write the transactions themselves into the replica. So we only need them to be in the relay log of the replica before we send that acknowledgement back. So this replica, in actual fact, doesn't need a copy of the data at all. All it's doing is saving the transactions and acknowledging the fact that it's received the transaction, not that it's committed it to its data store. So like synchronous replication, we still need a network round trip to do this. So it's best if we keep this in region to keep the performance up. We still need a replica available at all times. So we're going to need at least 2 of them, right? Because if any one fails at any point, the master won't be able to commit transactions anymore. So we set this up in a region where we have a master, two semi-sync replicas, they only store the transactions, they don't store the data, and we're good to go. So semi-synchronous replication works pretty well for us. I'll go through now how we implemented it and the kind of tweaks that we made to it over time. So the way we did this at Facebook is we modified MySQL binlog. MySQL binlog is an already existing tool that lets you pull transactions from, or tail transactions from a MySQL instance. So it will go and connect to the MySQL instance, it will pull down transactions, and it can even save a bin log to the local disk if that's what you need. We use this all the time for doing promotions. It turns out it's already pretty good at doing all of this stuff. All we need to do is modify it to send acknowledgements back to the thing that it's tailing, right? So not only now does it pull those transactions down, but it also says, I've got this transaction, you're good to continue. It'll say that back to the master so that it acts as a semi-sync client. This kind of shows it in a little bit more detail. So here we have a master and a replica. They're just using regular asynchronous replication. They're probably going into region. And we have two log tailors. A log tailor is just like an arbiter or an observer in the system. And it's running that MySQL binlog command that we were talking about before. So it's tailing the logs from the master. Each one of these is tailing the logs from the master and sending acknowledgements back so that the master knows that the transaction is safe. So we still need two for redundancy, like I was saying before. And we keep these in the region so that we don't have a performance penalty. But the replica, it can be elsewhere. That's totally fine. It won't hold back the transactions from being committed. Okay, so let's look into a dead master failover now with semi-sync and MySQL binlog. So it's basically the same as the async picture, but now we have this local log tailer. Again, I'm just drawing one here for simplicity, but the reality is you probably have two. So the transaction, so the master dies in a dead master failover, and the replica knows its position, its binlog position. So it can then go to the log tailor and find out its position, copy down the most recent binlog, and then replay that using MySQL binlog with a start position. At this point, we know that that replica is fully caught up with all of the most recent transactions, and we can promote it to be a master. And note that we can't just simply promote the log tailor because the log tailor doesn't actually have a copy of the MySQL database, right? So we can't answer regular queries from clients. Okay, so semi-sync works pretty well, but by default, it favors availability. Lossless semi-sync is available in MySQL 5.7 or the Facebook branch of MySQL 5.6, and it's really important to turn this on if you care about consistency. Here's why. So a regular commit flow, basically it does this binlog prepare, which is basically a no-op, InnoDB prepare, or whatever storage engine you have. Then we commit it into the binlogs, and then finally into the storage engine, right? And this happens for every transaction that comes in. Only once all four of those steps are done, we return back to the client and say, okay, your transaction is safe. With lossless the way that this works by default in MySQL 5.6 with lossless with semi-sync is we add this wait for semi-sync ACK as the final step before we return OK to the client. But this is a little bit of a problem. If we crash here, the transaction may or may not have reached the replica. If it hasn't, and we perform a promotion, the master now has a committed transaction that isn't available on that replica. And to make it worse, the transaction might have been seen by other clients. So in MySQL 5.7, or using lossless semi-sync, we can make this better by moving the wait for semi-sync ACK to before we go and commit down to the storage engine. This makes sure that the transaction is only visible in the bin log and not to other clients before we've returned OK. We still have a problem if we crash just before the semi-sync ACK though. The transaction might not have reached the replica. If it hasn't and we promote the old master, we now have prepared transactions that are not on the replica. The old master will want to roll that transaction forward if it ever comes back online. And to avoid this, on startup, we can make sure that we remove the transaction from the bin logs, or we just bin the instance to make sure that that transaction never makes it out. So it's not ideal, but it still works. So we spent a bunch of time building awareness of log tailors as a concept into our automation. We had to think about the full life cycle. We have to make sure that we detect situations where the log tailors go away, and make sure that we have new log tailors ready to jump in, because if we lose both log tailors, we can't take writes anymore. We hit some bumps along the way where sometimes our automation would pull both log tailors away at the same time, ending up with masters that aren't writable. Obviously, these situations aren't ideal, so we iterated on this a bunch and added a huge number of safety checks to make sure that this stuff doesn't happen. If you go to this URL, you can check out Simon Martin's talk from Pocona Live 2016. He talks a lot about that process that we followed to roll it out. The TLDR of it all is that our master downtime went down a lot. Once we finally rolled this out and everything worked well, we massively reduced our MySQL downtime. This is a great start, but there's still lots of work to do. You can still see a number of spikes that happen as our MySQL instances run into trouble. So MySQL binlog with the semi-sync patches we were talking about, this works pretty well, but we wanted a modernized code base. And the other thing is MySQL binlog, as you saw in that demo before, is primarily position-based. It doesn't understand GTIDs. We wanted to take what we'd built with this and try to build something a little bit more powerful. We wanted a platform to solve a variety of use cases to do with binlogs. And so we built this thing called Binlog Server. It's GTID-based, first and foremost, and it implements much of the MySQL protocol relating to replication. So the old MySQL binlog, it acts great as a semi-sync tailor. It can download these logs. It'll save them locally. That part's great. Binlog Server adds to this by adding a binlog reader as well. So not only can it save those binlogs, but it can also serve them to other clients. So instead of having the SCP files around, we can just connect a replica to the binlog reader component and have it catch up. Let me show you how that works. If we have a regular replica set using MySQL binlog and need to do a promotion, just like I showed you before, we have to copy this file and use MySQL binlog with a start position to figure out to get this replica up to date. But with Binlog Server, it's all a lot easier. If we lose that master, we can just grab the replica, point it to the Binlog Server that's already running on that log tailor, and use change master 2. The GTID auto-positioning stuff will just work, and it will pull down the transactions it needs to be up to date so that we can then make it the new master. This is a much cleaner, simpler design, and it made our automation a lot better. Binlog Server can do some other cool stuff as well, though. It's not just good for simplifying the dead master recovery. It has pluggable storage modules, so it can also read from things that are other than local disk. Hands up if you've run into error 1236 before. Few people, yeah. So this is what happens when a MySQL replica connects to a master, and the master doesn't have the older transactions that replica needs to catch back up. So if you've got a lagged replica, maybe by a few hours, but you only have 1 hour of retention on the master, you'll get error 1236 telling you that the master can't serve those transactions you need to catch back up. Previously, the only way to get around this was to just throw that instance away, copy the data across, and then hope that that copy finishes in an hour, so you can then catch back up with the most recent hour of transactions. But Binlog Server kind of gets around this. So if we have a greatly lagged replica that needs to catch back up, when it gets this error, it can just connect to the Binlog Server, which has this the ability to read directly into our binlog backups. And Binlog Server will be able to determine which transactions that greatly lagged replica needs, go and pull them from the backups and serve them to catch that replica back up. Once the replica is mostly caught back up, it can then switch over to the real master and catch back up to being basically caught up in real time. The other nice thing about this is that Binlog server understands all of the standard MySQL protocol. So we can run things like show slave status on it, and it will tell us the transactions that it has available to it. There's plenty more to Binlog server. If you search for Binlog server at Facebook, you'll find a bunch of different white papers and things like that. Unfortunately, though, Binlog server is really tightly coupled with the way that Facebook operates its stuff. So it's not open source yet. That might change in the future. But the good news is plenty of other people out there have built similar things. You can check out MariaDB MaxScale, which also has this kind of functionality and can act as a fully featured Binlog server as well. Okay, so distributed systems are still really hard. There's a number of different situations that are not covered by all of this automation that we've talked about so far. The other thing is DBAs don't really scale as well as MySQL does. As Facebook grew more and more, even though we thought we covered off most of the main issues to do with that were causing us data loss, the number of instances that we run result in still so much need for manual intervention. Our extensive sanity checks detect and call for us to manually intervene when we might detect data loss, but there was just too many for us. So let's talk about some of these situations now. As we started to dive into them, we realized that there was a few tweaks that we could make to either automatically recover from these situations or never encounter them in the first place. So if we jump back to the lossless semi-sync, the commit flow I was showing you before, those of you with keen eyes before might have noticed there's still a pretty major problem with this commit flow. Once the transaction has been committed to the bin log at this point, it can be read by an async replica, right? So if a log tailor stalls either MySQL bin log or bin log server and blocks that transaction from being committed on the master, some clients might still be able to read transactions that get replicated to the replica. Effectively, a replica can get ahead of a master. And the fix for this isn't as simple as rearranging the order. We actually had to break apart the thread, the common thread that we usually use for synchronizing bin logs from one instance to another. So we now have two separate threads that handle a semi-sync ACKA versus a regular async replica. So if we imagine a transaction's come in, it's been ACKed, both threads can see this transaction. What we change is that when a new transaction comes in, we move only the semi-sync thread forward. And this allows the semi-sync ACKers, the log tailors, to read those transactions and acknowledge them. But we don't move forward the async thread until we get that ACK back from one of the log tailors. At this point, we know it's safe to expose our other replicas to that new transaction. And the same again, new transaction comes in, we move forward the semi-sync thread, we forward it off to the async ACKA, the semi-sync ACKA to acknowledge, and only then do we allow the other replicas to read it. This comes with a little bit of a CPU impact, but it solves a variety of different issues. So the next problem that we encountered at SCaLE was a flappy or partially isolated master. So here's a little bit more, this is a little bit more realistic about how we run Facebook, MySQL at Facebook. We have this MySQL automation that is like an external service responsible for health checks and statistics gathering across all of our different replicas. And so we sometimes have this situation where if there's like network flappiness or something happens between the MySQL automation and the master, normally what would happen if this was a real, like the master had gone down, we would perform a promotion at this point. And since the network's gone down between these two, that's what we would do, right? The MySQL automation attempts a promotion, but once that's done, the master can't be made read-only. So we potentially run into a situation where if that master comes back online, the client could make a write through to that master, or even just the master could acknowledge a write that's come through from a client, and we end up saving a transaction and returning OK to the client, even though we've progressed on beyond that point and promoted to something else. So we need to find a way where we can make the master read-only, even if the master's down. We could do this by simply shutting down the master, right? Connect to the power infrastructure and just remove the power from it so that it can never send an acknowledgement back to a client. But these systems are often flaky, and we can't really know for sure whether this stuff's worked. We might not even be able to connect to the system that needs to power this off. But because of the log tailors, we've actually got an easier way of doing this. If we just isolate those log tailors from the master and prevent them from sending acknowledgements to the master, then we can know that the master will never send an acknowledgement back to the client. So there's one last scenario I'd like to talk about. And this is log tailor failures. So it's a pretty normal situation to have a single log tailor fail, right? If that happens, the other log tailor will send acknowledgements back to the master, and the master can continue making writes. While that log tailor is down, we'll pretty quickly go and grab one that's hopefully ready to go and drop it into place so that if that second log tailor fails, we can keep taking writes. But sometimes we still hit a situation where both log tailors appear to be down. If this happens, MySQL by default has a timeout. The default implementation of semisync will just disable semisync after this timeout and continue without the log tailors. This is a great idea if what you care about is availability, but it's a terrible idea if you're using semisync for consistency, because the master's just going to start taking writes as if nothing happened anyway, and we lose the whole, all of the properties that we just talked about before. So one way that we tried to get around this was increasing the timeout to basically infinity. If the master never hits that timeout, then it can never acknowledge a write. And so we rely on our automation instead to detect that the master is stalled and not able to make writes, and we do a promotion away from it. And note that this can be a live master promotion because the master's actually online. It's just not able to make any writes. As long as the log tailors are offline, this is totally fine, right? Even after the promotion, if the original master continues to be online, but the log tailors are offline, we know that no transactions can be committed. But there's still a chance that one of those log tailors will come back. It could just be a flaky network connection again. And so if one of them comes back online, we can then have the same problem that we ran into before, where the master will go and commit a transaction and forward an acknowledgement back to the client. So we need to find a way to prevent this as well. As a short-term fix, we can reintroduce the timeout, but instead of reverting to semisync, instead of reverting semisync, we can just cause the server to crash, right? If MySQL just exits and gives up, we know that the client will never get an ACK back from it. A better fix, though, is to introduce the concept of a log tailor whitelist. So previously, any log tailor connected to a master that sends an acknowledgement, the master will consider that acknowledgement good and send an ACK back to the client. But it's better instead to just list the log tailors that are allowed to commit transactions. And this is good because sometimes we'd have an extra log tailor transactions from the master that the rest of our infrastructure doesn't even necessarily know about. So the master, each time it gets an ACK, will make sure that it's from only the log tailors that it expects. And so now it's really easy for us to make sure that this situation doesn't happen. If both log tailors go down, the automation can just step in and say, okay, I'm going to remove both of those log tailors from the whitelist, and the master is then prevented from sending ACKs. And the nice thing about this is the master actually stays online, so we can still query it. We can still get transactions from it if we need to do a dead master promotion, sorry, a live master promotion. But it will be prevented from making writes that could potentially be lost. And another nice property of this is we can take those masters and potentially put them back in production after we replace the log tailors, right? Because the data on it is still consistent and the bin logs are good. It doesn't have any extra transactions that it shouldn't have. So overall, these situations are pretty rare for us, but at our scale, with the sheer number of instances we're running, we would run into these like often enough to justify the work. It was really important for us to get them addressed. So everything I've talked about today is open source. You can check it out on the Facebook GitHub. We have MySQL 5.6, where I think we have a MySQL 8 up there now, where we're slowly porting our patches across. The only thing that isn't included there is Facebook's binlog server, for the reasons I talked about before. But you can totally get the same kind of functionality with any of the other ones that are available out there, including MariaDB, their SCaLE product. That's it. My name's Sam Dunster again. I'll be sticking around just for a little bit to answer any questions. What have we got? About 15 minutes. So yeah, I'd love to take some questions. Otherwise, I'll be at the Facebook booth right after this if you want to come and talk one-on-one. Thanks for coming. Any questions? Hands up. Yeah.
Could you comment whether you're using statement-based replication or row-based replication in this?
Yeah, absolutely. So the question is, does Facebook use statement or row-based replication? What I talked about today totally works with both. Facebook still uses both. Our primary workloads are all row-based. We found that for our use cases, that generally tends to work better. It's more performance, and I think there's a few edge cases that it helps us solve. But some of our other like smaller workloads and various different things we have out there are still using statement-based replication. I think the aim is to move towards RBR, but we're not sure yet. Yeah. Any other questions out there? Yes. Yeah, I can't really hear you. It might be better. Might be better if you come up the front. Yeah, sorry. Yeah, I could do that. Yep. Maybe send me. I don't know. Does anyone know if SCaLE publishes stuff? Yeah. Yeah. So they'll be published through. Yep.
My question is, group replication, are you guys going to use that?
Is Facebook using group replication? No, not today. We're evaluating different options. There might be some of our use cases that make it worthwhile, but today, no.
Do you run all database servers on bare metal?
I'm not sure that I can talk about that, unfortunately. Yeah.
How about containers? You cannot answer that,
I mean, we use systemd, we use cheroots, we use cgroups. Yeah.
Maybe sometimes you'll moving the binlog server.
Will we open source binlog server? I can't really speak to that. Today it's still very tightly bound to the way Facebook runs their infrastructure. It's not something that I directly worked on, so I can't tell you. But you should totally check out MariaDB SCaLE. It works good.
One thing about that, it's not open source.
MariaDB SCaLE isn't?
It was open source, it's not anymore.
Huh.
Now it's source well. So you
Okay.
cannot use it unless you subscribe or
Oh.
MariaDB commercial.
I'm sorry to hear that. I didn't realize.
But there is now an open source binlog server from Google.
Yeah.
I don't know what the name of it is, but you can.
Cool.
Maxwell. Yes. Maxwell. Ah, okay.
Can I?
So my question was, there was a talk earlier on setting up clusters to SQL with Kubernetes with one writer and two readers, three clusters, and you scale those clusters out pretty more. You read logs and everything. How does that compare with that approach?
I think it's pretty different. Hang on. Let's
Okay. Okay. Sound check. You hear me okay, right? Okay, that's wonderful. So we'll start in about 2 minutes.
Okay, well, it looks like it's time to get started. So, first let me ask you a question which is very near and dear to my soul. Do you guys, how many of you know what is Percona and why I'm speaking about MySQL query optimization? Okay, well, thank you for raising your hand. For those of you who don't know, Percona, we company which specializes in open source databases. We started with MySQL, that is where my most background comes from, but now we also focus on MongoDB and Postgres as well. We do a whole bunch of services ranging from support to consulting, management services, training, and what is also important, what we release a lot of software for MySQL and our open source database ecosystem, and all the software release is open source. We don't do open core or any other things. So now about the presentation. We'll cover the basics of query optimization in general, and that will actually apply to any database you are thinking about, most of it. Then I'll talk about the way what MySQL executes the queries, which is very important to know if you want to optimize them. Then you'll talk about how to find the queries which you should optimize, and really how to optimize them in the end. If that's not what you came here to hear about, then we actually have even 2 doors which you can leave from. Okay, the basics. Now, some of you may find that obvious and very trivial and simple, and would wonder, why do I speak so much time covering the basics? But I think that the basics are a foundation and the most important, because that is the thing which is harder to Google, right? If you know, oh, you know what, I need to do X, right? It's typically easy to Google the problems for solutions, right? But if you don't even know what the problems you may face, then it's kind of hard to find solution for. So let's look first at our main goal, which we look at with query optimization, right? And it is their application performance. Because if you go high enough, right, company management and wherever, we typically care about user experience, and they care about the application performance, not specifically the database performance. Now, what is that great performance means? And I think that means what you have your users, which get the response, which is a low response time for them, right, which happens for all users at every time, right? You don't have something like, oh, in the middle of the night when I'm running my backups, things crawl to halt, right? Or some users are suffering some of the time, or something like that. Now, their database is not always responsible for the performance, of course. For some of you, that may be very trivial, but I can tell you how many cases I had when I come to a customer. I look at the system and look at database, there is not a lot of load on it, and I ask, why do you think it's database? And I say, well, in our experience, it's always a database. Anybody had that experience? Yes, yes. And then it turns out it's some, stupid DNS misconfiguration, and they're actually sending the application traffic to the equivalent of a network dev null, right? Okay. Now, database can be making your application slow, and that actually can come both from the issues which come from the dev side as well as an ops side. From development side, you can have following things which are often cause application performance to be bad. For example, many queries being executed serially. That can be very bad. Now, I remember visiting one customer, had a web page at that time, which would be reloading very, very slow. And when you looked at how many queries you would have to generate that page, that was about 100,000 queries for a single page, right? Run one after another, right? And in this case, that is a bad idea, right? Even if your local network latency, those things add up. Obviously, running expensive queries, poorly designed queries, or queries which haven't been optimized, that is also can be a problem. And also from development standpoint, I see often mistake done by overloading the system and causing saturation with some additional workload. For example, if you think that Java developer tries to insert 1 million rows in a database, right, and it is going slow, what do you think that Java developer will do? I know Java developers do it, probably some other do as well. Any ideas? Well, they'll go and do it from 100 threads. If that's not enough, 500 threads. Now, they may be able to insert that 1 million rows, right, where that number is faster, but guess what happens to everybody else on the system, right? It would cause that overload. From operating ops side, we often see the problems with various with a system, right, where there is a hardware problems or choosing inappropriate system scale, network or storage misconfiguration. The same thing with saturation with additional load, right? Things like doing backup in the application traffic, stuff like that, and also not doing appropriate capacity planning, right? Because obviously database have a certain capacity, right? It's not magic. It cannot throw any load you throw at it, right? Even if your queries are reasonably optimized. Now, I mentioned the serial queries already, but I wanted to point out again that it's very important to mind the network latency, right? And why is that important? Especially because we operate in so many different environments. So if you are a developer and let's say doing some development of your database on your laptop, right? You actually don't have any network latency, right? Then if you operate in the data center, right, you may be operating with a single hop, right, a very low latency. Now, if you are moving to the cloud, and you can say, well, I'm operating my system through different availability regions, right? That can give you latency which can be several times higher than in your very tightly coupled data center, even before you go to some multi-regional deployments, right? And in many cases, what we see what those things are not understood correctly, right? And then the database is blamed for performance issues, of course. I remember, and again, a few years back, talking to somebody who had a very bad application performance. And we talked to them about the network. Well, what is your network speed? And they say, well, my network speed is 1 gigabit. And that is at the time that was kind of okay. And say, well, that's fine. And then you ask more details and what he means. Well, he actually meant what he has a dedicated gigabit link going about 1,000 miles to reducing the data center. From his standpoint, he thought what a gigabit is good, right? And he didn't think about the distance and the light speed, right, and the latency. And that, I think, is a very common a lack of understanding you can find among developers, right, which can get to bad results. Okay, so moving on closer to our query optimization goals. So if you are tasked with optimize certain queries with MySQL, those can be coming from several different needs or reasons. One is you have a specific user interaction which is slow, right? For example, oh, when I am trying to do a search or run a report, right, or load certain page, it takes just way too long time, right? You want to optimize that. Another thing you can say, well, I want to optimize the whole application. It's how we can, find what is out there of optimization and generally to improve performance throughout. Now, another task which can be seen, well, those days, especially in the age of cloud, is improving efficiency. And what that can be saying, well, you know what? Yes, we can run our application at a good performance, but it is not really cool what we have to run large number of the largest instances on Amazon, because those things are pretty damn expensive, right? And what we want is to find how we can improve efficiency, so we can either consolidate and run less service, right, or scale down and have a smaller instance size, maybe not over provision storage performance, and so on and so forth. What cloud makes it wonderful here is what if you increase efficiency, you can realize the benefits very quickly, right? You don't have to wait until your contract for renting those 100 servers expires, right, or until you do something else. And another important thing is assuring scalability. What I mean here is your application may be well working okay so far, but if you're expecting to grow 5x, 10x, 20x, you may want to review your queries and to make sure they are not going to give you a problem when you scale. Why is that important? Well, that is especially important because not all the queries scale linearly. And especially poorly optimized queries, they may have a very bad kind of scalability curve, right? When you grow your data, for example, by 10x, the query may be 100x slower, right, 1,000 times, right? Which can be great surprise for somebody saying, well, I just doubled number of my users, right, and it was super fast, and now it's super slow. Why is that? Now, of course, you should not look at the query optimization alone, right? A lot really depends on the general application architecture, choosing the right technology, not only MySQL. MySQL is good in certain things, but there are many, many things which MySQL is absolutely horrible at, and you're just better off using other technologies. Obviously, using a proper hardware size, right, and storage configuration, and so on and so forth, right? Especially in a modern cloud environment, you can get probably 100x difference between your very small instance size and kind of some very poor performance storage, right, and the largest instance sizes you can get. Operation system and MySQL configuration, and of course database schema design, right? You need to look at all of those, right, really in combination, and make sure there is no weak points. Okay. Now let's look at how MySQL execute queries. And I told you what already MySQL is absolutely horrible in certain things. What are those things? Well, if you look at the modern world, those are kind of sounds horrible to me. The fact that the MySQL executes single query on a single server, right? So you can't scale out and say, hey, I put out there 200 servers, and now my queries are run a lot faster. Even worse, at the times when a single server can have more than 100 virtual CPU cores, it's still optimized single query in a single operating system thread. That means it will be run on a single CPU core, right? And also, what is very important to understand, while MySQL has a thing called query cache, it doesn't care intermediate results between, it doesn't cache intermediate results between the queries in any way, right? So, for example, if you would be running some heavy group by queries, right, it will process and aggregate all those rows all the time, not some compute those automatically for you, right, and cache as some systems do. Here is the query execution diagram. Yes, it's wonderful, but probably half you cannot see it, and so you just have to believe me. The idea here is what as the query comes, MySQL would check the query for the query cache, right, if that's enabled. Then the query will be parsed, right, and the next important component there would be the optimizer, which will apply various transformation and then find to build the best execution plan to optimize that query, right? And and then that plan will be pretty much executed using one of the storage engines. The most common storage engines in use right now is InnoDB, but let's say the folks from Facebook who spoke before me, they use mostly Myrox those days, right? That's another storage engine which they have built in-house, right, and which they spoke in many other instances. Now, there are some added complexities to this especially simple diagram. For example, you may have some UDF, user-defined functions. If those are expensive, then can drastically change your query execution, or even stored views, stored functions, right? Then you can use a function in the query which itself uses a bunch of queries to produce results. The thing with MySQL Optimizer, it's kind of dumb. It doesn't really put any cost on those function calls, right? Even if it can, and does not try to create a plan which minimizes the number of those functional calls. Another troublemakers would be such things as triggers, because you may be thinking, oh, I'm just making one row insert in this very simple table. Why is it taking so long? Well, because you have a whole bunch of triggers on this table which do some magic stuff. Views is also quite things you need to keep in mind in this case, because you may think what you're just selecting, making a very simple table on the query on the table, but if that's a view, then it actually may require some a lot of processing, right, to of a view, and especially because the view in MySQL can also be defined in a cascaded way, so you can have a view which do the queries on other views and on other views, right, and you can create such a complicated monstrosities, if you like, right? And if you come from Oracle background, you probably do like. Yes, but MySQL doesn't like it, right? MySQL is for for simple-minded people, like. Okay. Now, another thing which you have to mind with MySQL is use the limits, right? If you only need 10 rows from result set, apply the limit. Don't write the application when you run the query and then you fetch the 10 rows and stop, right? Because the MySQL client-server protocol is implemented in a way it always will have to send a full result back. It cannot stop in the middle, right? It doesn't have a concept of some other database technologies of sort of a cursor where it will first prepare and send you, let's say, first 100 rows, and if you want more, it will do whatever it has to do to produce more for you, right? MySQL operates the full results set all the time. Okay. The next thing to keep in mind about MySQL execution is a field called join order. So if you think about the query, it will use a number of tables. Some of them would be your original table. Some will be derived tables, such as if you have subqueries in the from clause and some others. And MySQL will have to pick an order in which it will join those tables, right? And then to sort of process them after one another. Now, this join order is absolutely critical for performance, right? MySQL tries to choose the best join order, but it's not always able to guess it right for various reasons. Now, if you want specific join order, you can either use those select straight join hints, as I mentioned, or there are also some other optimizer hints you can use in new MySQL version to define the table order you want to use. Indexes. Well, proper indexes are absolutely must-have for optimal query execution, right? And to make it clear, it's very possible to have indexes improving query performance by 1,000 times or more. In many cases, you're thinking about a query which kind of never would have completed in your lifetime, and you indexed that, and the query completes in fraction of a second. But at the same time, indexes are expensive to maintain. So I mentioned that the indexes are not free, but what is the cost of those indexes? And there are actually a lot of different things here. Of course, indexes take space on disk, right? They also take space in memory, where they compete in the cache with the data, right? So if you have more indexes, you have effectively less memory for a cache. Everybody understands, like, or many people understand, what indexes are expensive to maintain with updates, right? So they make updates expensive. But indexes also make select expensive when they're not used, because the optimizer has to consider all those indexes, sample statistics from them. Is this index good for that query or not? And if combine that with the different table orders, right, then which it can use, right, then that creates a lot of potential combinations, right? You have a few tables which have a lot of different index combinations to use. So so be mindful with an indexes, right? I would say one way I can take a look at a schema and say, yeah, that is schema is done by a clueless person, is when I have a table and every single column in that table is indexed. There is no multiple column indexes, nothing else, just all the tables are indexes, because, yeah, indexes are good, they make query faster, right? Columns. Now, if you look at the MySQL from the data storage performance, it's what's called the row-based store. That means you have all the columns stored row by row, and what that means is when you access the data, all the columns from the row, they have to be read together, with a small exception of blobs for in a DB table. So what that means is what the number of columns you have and the size of the data in those columns will impact the query's performance on this table a lot. Now, there is an interesting trick, though, right? There is a data structure called covering indexes, right? When you essentially have an index, when you add the columns you are planning to select to that index, even if you are not using them in a where clause, and that allows MySQL to read all the data from index without going to the actual table, right? And that is a very nice trick for high-performance table, especially for wide columns. It can do magic. The next thing you need to remember is character sets, right? Not all the character sets are created equal. You know, how many of you use emojis here? Okay, and the rest of you, come on, be honest with yourself. Right? So if you use emojis, right, then you need UTF-8 character set, right? You cannot use Latin 1. The thing is, the most benchmarks you see out there, right, and the default in MySQL before MySQL 8 is Latin 1. And as you can see in this graph, what going to UTF-8 character set can give you, 40% or more overhead, especially for some queries. And here is a link you guys can use to read more details about the benchmark and all various additional information. The great news in this case is MySQL team at Oracle, they understood this problem. They put a lot of work in MySQL 8 specifically to optimize it for UTF-8 character set, right? So we can see it's more complicated character set, right? So it's hard to make them equal and have absolutely no overhead, but you can see it gets much closer, right? If your overhead being much more tolerable, maybe 10%. Okay. Now, another thing you should look at when you look at your query optimization is some additional processing which may be reading besides filtering and retrieving data from those tables, which could be grouping and sorting. Now, MySQL has a whole bunch of different algorithms it can use, right? Which I don't have a time to explain, but pretty much amount of data you sort, right, or group by matters a lot, right, in this case, and you want always to minimize that. If you can sort by shorter column, it will be faster, right, for example, than if you're doing the sort by a longer query. Okay. Now, do you know how MySQL Optimizer works? Anybody? No? Okay, yes, here is a hero from himself on my next joke. So, I would tell you what no one knows how MySQL Optimizer works in details really at this point. We have been through what is like more than 2 decades that there are so many rolls of duct tape was applied to a MySQL Optimizer. I mean, I think it's a mystery to everyone, right? I mean, obviously, we all understand the basics, but it's like, hey, why it would do it this case and this case? Well, let's take a look at the code. Oh, yes, yeah, that is that little optimization, right, shortcut we have employed here. So anyway, but in principle, MySQL Optimizer is designed to provide the best plan, which is at a minimum cost, right? It's not trying to run your queries faster, right? It doesn't kind of measure query execution time and try to apply machine learning and genetic algorithms to reduce that, right? It tries to come up with a plan best it can to reduce the cost, and that cost model is just a model, right, which can be right or wrong for your environment, and it's constantly being improved, but as with any model, it's not perfect. And it also relies on statistics, which, as you know, there is lies, downlines, and statistics, right? Even in MySQL case, right, you may be lucky and it works for you, or you may have your stats for tables be very wrong. So what I would suggest here is to, even though nobody knows how all the MySQL Optimizer works, you want to learn what MySQL can do in terms of its execution, right? Because what kind of methods exist, right? Because especially if you have some background, right, in relational database, you can think, well, you know, I think their distributed sort merge join would work wonderfully in this case, right? Why is this query slow? Well, because MySQL Optimizer doesn't know those things, right? It only can do certain it can do, right? And if you, but at the same plan, there are maybe certain tricks that MySQL Optimizer does for query optimization, which you know you wouldn't aware. Now, if you really think that you are smarter than MySQL Optimizer, and that's okay to think this way, you can use the optimizer hints to force the order of table and join to work specific indexes and so on and so forth. And you know, that is one of the best things you can do if you can say, well, you know, why MySQL Optimizer is so stupid? There is this obvious plan which is much better than selected. Try it out, right? Force that plan for that query and see if you're actually right before investigating more, because maybe that plan is actually slower, or maybe MySQL simply cannot do what you wanted to do because of its execution limitation. Learn explain statement, right? That is a way to optimize how MySQL expects to execute the query. Now, what is important there is, while their explain is likely to give you correct information for the given server at that period of time, it may change over time, right? For example, data changes, maybe timestamps which are hard-coded in the query, you know, can change over time. With data changes, statistics are going to change, right? So for the same query, execution plan and so explain output may change. So don't expect that if I test it with given query, with explain, is well optimized, it will stay there forever. So here is optimizer, what a MySQL explain looks like, right? A very simple table output, right, for our single row query. And if you look at a MySQL optimizer, one of the big things that you want to look at is this number of rows, right? If a number of rows is large, it's 10 million, right? Then that means it's very likely to be bad query, right? At least you probably want to dig into that more, right? Or if you have a lot of tables in the list and each of them has large number of rows, right? Because you kind of have to multiply those numbers to get to a number of rows MySQL may theoretically analyze. Extra is another important one, right? So if in this case, using index for group by is actually is good, right? That is, MySQL is using the new optimization of a skip index scan, which is good. But if you have here like using file sort, right, using temporary table, that means these are some additional steps and additional complexity what this query requires. You can also use extended explain. What extended explain does, in this case, it converts the table, it converts, well, it provides you the same explain, actually, output, but what it also creates is a warning, which you can do show warnings and see what that query was kind of internally rewritten to, right? What query MySQL is actually going to optimize internally, right? And then you can see in this case there are some additional things have been added here to explain what's going on. Also, you can have explain JSON format. JSON has even more details in its output, right? And which is a very valuable for advanced query optimization, right? If you really want to understand more details about execution plan. Now, if all of those kind of looks you know, boring and kind of too much text, you can also check out the MySQL Workbench. It has the tool built in where you can call Visual Explain, where you can actually see that structured much more visually to you, right? And that pretty much uses JSON explain to visualize those data. Okay. Now, one problem with the execution plan you get from explain, this is just one plan, and you may wonder, okay, how did optimizer get to that decision, right? If you want to understand that, which is needed in some advanced cases, right? Maybe you found optimizer bug or wherever. There is also a feature called optimizer trace. With optimizer trace, you can enable a trace when you would run the query, right? And then you would be able to see in that information schema optimizer trace the large JSON output which tells, oh, I considered this, I considered that. There was, you know, those you know, partial plans I consider, right? So there is a lot of information out there which can be hard to read if you're not an expert, but it can be at least very helpful to do things like report a bug. Okay. Moving on next to how to find the queries to optimize. And here comes my next question. Now, where do you think you should optimize your queries? Should that be in development environment or in production environment? Who likes to optimize queries in production? And okay, and what about development? Okay, yes. Yeah, I see. Like, oh, optimizing queries as developers, that is not fun at all, right? I mean, well, in reality, the good way is to do both, right? One is, of course, when you look at the queries in development process, you want to make sure you catch bad queries before they go to production. Slow queries, scale queries which will not scale, and so on and so forth, right? But at the same time, you will get crap in production, right? That applies to MySQL queries as everything else in life. You want to be able, you can to troubleshoot those queries in production as well. Now, what is interesting in this case is even if you cut all the queries and very, very good and correct queries, right, and there was everything working perfectly in your kind of query quality assurance process, you can have things like MySQL Optimizer goes, you know, sideways, maybe stats become wrong, right, and query plans break, right, which you have to deal in production. So if you're looking at development, actually one of the ways you can use is you can enable MySQL slow query logs, set long query time to 0, and take a look at the queries you get. Or maybe you have tools like you know, New Relic and other application profiling tools, right? Or maybe even your framework provides you the list of queries the page executes. Now, one optimize to look not only for the queries to optimize, but also look for waste. I can tell you from in majority of cases, if I go ahead, come to development team, say, okay, let's look at the queries which page generates, right? And then you take a list, and then I'll say, why do you need that query? Why do you need that query? Oh, well, we don't use that code anymore, but we just, you know, to run that query anyway because whatever, right? And I can tell you in majority of cases there is quite a few queries which just do not need to be run. They produce the data which nobody uses, right? So check it out in your in your environment and see what you'll find. Now, if you look at the both development and production, you can use a number of tools to analyze the queries. And there are a lot of good commercial and SaaS tools. Oracle provides MySQL Enterprise Monitor. There is tools like Vivid Cortex, right, and others which you can use for this side. From our side, we also wanted to make sure there is an open source solution for that problem. So we have created Percona Monitor and Management. That is the tool which you can use to analyze your queries in production, among other things. You can check it out live at this website, and that gives you more impression, right, than what we will show in this presentation. So one thing what you can do is to find the top queries which are causing the load, right? In this case, you can see the queries sorted by the load contribution. Now, what is important in this case is to understand what your outliers, that queries which was the longest one and it took 5 minutes to complete, may not be query which causes the most load on your system, right? So it may not be the first one. The second one is it's actually very hard to understand in general which queries are victims and which are causing the problem, right? Because think about this, right? Even if you look at the query and say, oh, I'll look at the query how much CPU I/O and it causes. Then I may have a query on the side which runs and pretty much washes off all my cache, right? Just removes everything from my cache, and because of that, other query has to do a lot of I/O, which actually it shouldn't, because all its data should be well cached in memory, right? So that is a kind of hard problem to solve, but in many cases you don't have to. If you go through your top queries and you know, you go through first couple of pages, you will find both offending victims, right, and the queries victims and offenders at the same time. Also, you should be mindful about the queries which may not be finished yet, and so they are not seen in slow query logs or performance schema, right? In many cases, you will find developer to trying the application a few times and waiting for, you know, few times until browser times out and saying, okay, well, that didn't work, right? Trying something else. And then you look at the MySQL server afterwards, you may find there is like 10 queries running. Some of them have been running for 10 hours, right, or something. In MySQL, actually, there is now a very good feature which is called max statement time, which you can set, right? I don't know, say maybe to 5 minutes, to 1 minute, whatever applies in your environment, to make sure what the queries which are running for a very long time just get killed. And you can set that as a per session variable. So that means you have some batch job which does need to run 10-hour queries, then they can run, but your typical interactive application don't. You can also check out their the query profile, which can report a lot of information for given query, right? You can find why this query is slow. For example, for this query, I can say, well, it's actually causes a lot of InnoDB I/O, right? And then you can see what 56% of that query time comes from it doing disk I/O. So if I want to optimize that query, I understand I need either faster, faster disk or more memory. Also, you may want to check to understand how efficiently query produces results. So, for example, in this case, we can see, if you can see it, what that query has to scan 30 million rows for each row it sends back to a client. That is not very efficient things to do, right? Now, and those are either expensive queries or poorly indexed queries, but that is something that often needs attention. And then also we have some tools like you can look at explain, you can look at the table details. The goal for us is to make sure provide you all the tools you need on a single page, being you either DBA or developers. If you want kind of to look more of that in practice, one of our support engineers just published the case study about using CPU to using the PMM to reduce the CPU usage, right? Yeah. Okay. Let's talk about how we optimize the queries, and I will be rather brief in this case. So first, as you look at the query, you want to look at the query stats, right? Whether that is in the PMM, or just by running that query and looking at the counters difference. For example, how many rows did the query crunch, right? Or how many rows it returns. Again, if it returns 10 million rows, then the question is, does your application really consumes all of them, or maybe you forgot the limit, right? If it crunches 10 million rows and returns you 10, maybe it's not indexed well, or maybe it's just an expensive query. You want to check how much I/O is required. Do you have required temporary tables, temporary sort files? The next thing that I would do is to run explain, right, and to understand, is the plan reasonable, right? If a plan is bad, that is fantastic, because you have an opportunity really to make quite a difference, right? You may find what the indexes are missing. You may find what there are some bad optimizer statistics, or you may find some things which are just done poorly in the query. So, for example, if you have a column, if you have an expression on a column which when compared to something, then MySQL would not be able to use the index in this case. Now, that is something what you may think, well, I mean, why wouldn't it be just able to figure it out, right? That looks like a basic math. Well, it doesn't, right? So you just would need to change that to have an expression on the value which is compared to the column directly if I want that query to use the index. Expensive queries. There are certain queries which naturally would do a lot of work, right? So, for example, if you say, well, I have 10 million orders, right, in a database, and I want to look at the average order value, right, for last 10 years, it will need to crunch through lots of rows. And what do you have to do with them? Well, it's pretty much good to get rid of them, right? I mean, you also can consider caching them or pre-generating results, right? But just to make sure, especially if you have your interactive application, trying to run those queries, that is a very bad idea. Often it's good also to separate them in space, right? And what I mean by that is by running them on another MySQL slave, right? Heavy queries, which is not the same which your real-time traffic serves. Now also you should look at the systems which support such queries much better. Certain kinds of queries, right, they may have a lot of conditions, which is very hard to pre-create and very hard to cache, right? But there are also a lot of systems which are massively parallel, and especially the column stores, which even on the single node, they can run the query maybe 100 times faster. And because you can scale them with a large environment, right, you can get performance many thousands of times better, even if you are actually doing all that kind of work. So in this case, this is actually comparison of some of those systems. There is no MySQL here because MySQL will be at least, I think, 10 times slower than all of those here. And you can see what we can look at the things Spark, column store, and the ClickHouse here. All right, you can see what the MariaDB column store, it's kind of the closest to MySQL in terms of supporting the protocol, but because it kind of have to be bolted on to MySQL in some way, it's also the slowest, right? And then you can see their second one is a Spark in this case, and the fastest one is a ClickHouse, which is something like some very heavily optimized, massively parallel C++ code. So if you want to optimize your queries, which process huge amount of information faster, consider offloading them from MySQL to something else. Optimizing writes. Now, what if not reads, but writes are the queries you want to optimize? Well, let's start with two things I don't mention here. Is two things which you can avoid using this improved performance are foreign keys and triggers. Right? I know in some cases you must use them for compliance, for auditing, for data consistency. If you must, you must. But understand that these are expensive things for updates. You also want to use less indexes for updates because maintaining index is expensive. You want to try to fit the data in memory because in memory updates are significantly faster. You want to batch your updates. What that means is if you have to modify, a million rows, don't do that as a million of points updates every single one in its own transactions, right? You want to make sure that you combine multiple queries in the same transaction and do some batch on the query level if that's possible. Using partitioning, that also can be very good feature to optimize writes, and also potentially using different storage engine. Specifically, MyRocks, right? That's what I mentioned Facebook uses, especially if you have a data which is much larger than your data set. It can perform substantially faster than InnoDB. Now, this is complicated picture which is created by our CTO, not by our marketing team, right? So it's very hard to read, but there is a lot of meaning here. So, so in this case, you can see what the yellow is MyRocks, and you can see it's very stable wherever your data fits in memory or doesn't. And you can see for InnoDB, if a data doesn't fit in memory, then it can be, multiple times slower. And then if a data fits in memory, then it will be, a few times, a few times, right, but 20% faster, something. Okay, well, with that, I have few things I also need to cover, quite obligatory. The first one, we have a wonderful person in this room which you absolutely need to know, and this is Dawn. Yes, and she is also will be out there on the booth, right? So if you want to talk about Percona business, talk to her, you know, not to me. You can talk to me about technology and, you know, various fun stuff, right? Okay, now also we are want to know how you are using their open source databases. So if you could kindly fill out our survey, open source database survey, right? There's a little link here. One thing we promise to do is two things. Is A, that is anonymous, so we don't collect email address or anything like that. Sorry, Don, but you won't be we won't be using that for lead generation. And then we're also going to share results with all the open source community, so you can analyze it in the same way that we can. So if you can take a survey, that's fantastic, and if you can even promote that through an open source database community, that would be even better. And also, if you love open source databases, we are running the conference, Percona Live, open source database conference. It takes place in the end of May in Austin this time, so we would very much like to see you there. And with that, I have a few minutes for questions.
I'll give it a couple minutes. I think people are coming, I hope. Okay, good afternoon. I'm Gabby. I am a developer advocate for Google. Today I'm going to be talking about core analytics for day-to-day developer. If you were at the talk previous to mine, this kind of may contradict what Peter said, but not in a bad way, because everything that I'm showing you here, it's new features that are on MySQL 8, and the goal of this, it's not to make you use this on the everyday, but you know when you have to generate their report for the marketing team to the business team, and it needs to be ASAP, and the data is not synced with the Redshift, BigQuery, whatever it is, and you need that most up-to-date data. So that's why this talk exists, is to teach you how to process information using MySQL as you would do on a business intelligence database, on a database for business intelligence. So this is me. I try to solve all my problems using a single query. I don't like writing scripts. I'm lazy. I like writing SQL. It's easier. It's declarative. I don't have to think much. It's much easier for me. So that's me. Sometimes it isn't always pretty. No. Sometimes it's not pretty what I'm doing. It's actually a hack sometimes. And I was bored in one of those days, and one of the things that I thought was like, can I do fizzbuzz on SQL? Yes, you can. It turns out you can do fizzbuzz on SQL. It's not pretty, but it works. I'm not gonna teach you how to do that, but like I'll teach you what is going on there in a few moments. So, brief history about MySQL. It's 23 years old. Before it was created to handle from 10 to 100 million rows up to 100 megabytes per table. So not much data actually. Now supports terabyte size data sets, and standards from 2016 and some from 2003 yet. Like window functions, the CTEs are new to MySQL 8, but they are not new in the SQL standard. Other databases has it for a while, like Postgres, Oracle, and SQL Server. So right now, MySQL is in the version 8.0.16. It's brandly new, but what I have here on my demos are version 8.0.15 because this is like not even a week old. I didn't install it yet, so I don't know what's that different. I think there are some bugs that they solved. So right now, I'm studying MySQL 8 since 2016, since version alpha 8.0.0. So a lot of change since then, and a lot of things were added. I gave this talk a couple times, and every time I give this talk, there's new stuff to talk about. So that's the cool thing about following up the upgrades. But be warned, don't do everything I'm teaching you here, don't do this in production. Just because you can doesn't mean you should. And the cost of analytical queries is really high on the database. So if you're doing it, do in a replica. Do not do on your production database. Because by mistake yesterday, preparing for this talk, I made a SQL error, and my query ran for an hour and 20 minutes until I figured out what was going on. So yeah, do not run on production. And remember, this is just to help you on an emergency, and in the end, you're gonna, whatever I'm learning here, the main concepts, the syntax may change, but you can use on Postgres or BigQuery or Redshift, it's the same. So I'm gonna start here showing you why you shouldn't do this first place on the database. Okay. This is BigQuery. It's not the face of BigQuery, but this is it's connected to BigQuery. And if you do a count, I have a table order items. I think it has 200 million rows. And it has 280 million rows, and it took 1 second and 359 milliseconds to run. This is on BigQuery, which is made for this amount of data. It's an 11 gigabyte database. Now, let me change here. Scratches. If you run the same query, I'm going to let it running. It's going to take, I think, 45 seconds to count the same amount of rows there are on BigQuery. Oops, wrong database. To count the same amount as BigQuery. I'm going to be explaining the differences, but this is why you shouldn't be doing on a production database, because counts really are, as Peter said before, average sums, counts, any aggregate functions really heavy on the heavy load on the database. So if you have to do it, please do on the replica side. I'm going to let it run, and then we come back to see how much it took to run. A few considerations too. I want to know how often you write raw SQL. A CRUD operation, how often? Like, who here is a DBA? And who here is a normal, not normal, normal is weird. Who is a software engineer, developer, technical practitioner? Okay. So you mostly are using either Active Record or some kind of ORM to do your day-to-day CRUD. So you really are writing CRUD operations on your own raw SQL. And DML operations, alter tables, updates, creates, that's even more often than the CRUD operations. Have you ever created, edited a function on the database? Or a procedure. I have done in my career program PHP oriented to procedures. Everything had to be on a procedure because they thought the PHP wasn't safe. So all business logic was on a procedure. So that was the programming oriented procedure. And more commonly a view most people do, but then you need to have privilege to create a view. Have you ever generated reports using a scripting language? Like, I want to know how many people bought this product, and in the end you can't do with a single query, you need to do with multiple queries to bring up, and you ended up using a scripting. So what I'm going to show you today, you don't need to do that. You don't need a scripting language to do that. You can do that without SQL. And an ETL, which it is extracting from the database and serving to another, whatever database, other database there is. And if you ever synced data across different types, like Solar, Elastic, you see that sometimes is a pain to keep the data up to date with those kind of databases. So this is why sometimes you don't want to wait until your data it's on a data lake, it's on a BI tool. You want to do whatever it's on production. So I have a scenario here. I have a store that I created. The store has 4 tables: products, users, orders, and order items. This is the relationship between the tables. User has many orders, order has many items, and product belongs, order items has a product, and product can have many ordered items. So it's a oversimplification of a commerce system. And you want several reports. You want to know what is the most expensive order per user, the highest price of each product was ever sold, and what date was that purchase made, and the monthly amount sold in a year together with the growth. All of these things you can get on a BI tool, but or even using a scripting language, but it's going to fire up a lot of queries and probably is going to take way more time to generate than in here. Which leads us to subqueries. Dave said in the morning, Dave Stokes from Oracle, subqueries are kind of evil. We avoid writing them, but sometimes you do this. I have a table users. It's oversimplified here. It doesn't. You look, there is no primary key, but there is on my database a primary key. I just didn't put it because it didn't fit on the slide. And on my table users, I have ID, username, created at, and updated at. When you select from users, what you get is ID, username, created at, and updated at. That's just that. Nothing. It's oversimplified again, and GDPR compliant. And the most, let's say you want to do the most expensive order for each user. Did you ever put a select, a subquery inside a select before in your life? It's not pretty, is it? You see, it's the same select twice. I'm just getting like, here I'm getting the ID, and here I'm getting the ID of the order, and here I'm getting the total of the order. So I had to write twice. So it's executing this for each row. So MySQL 8 has a new thing called lateral join, which allows you to do a join on the result set using a subquery to bring the same result set. It looks like this. In the end, instead of having 2 queries, let's say you wanted to bring the status too, because when you do a subquery on the select, you can only return 1 column, and using lateral, you can return how many columns you want. Like here, I'm returning ID and total, and you can see here, I am using ID and total from total orders, which it is my lateral table that I created in here. But how does that work on real life? So I'm going to close this. Oh, the count finished. It took, no, that's the other count. 38 seconds to count the same one that BigQuery took under 2 seconds to count the same amount of rows. And it is the same amount of rows because I imported the same table twice. So let me show you how that works. So this is the query that's in there that I showed you before. This query is going to run fast because I'm just limiting by 10 users. Wait. And you see here, there are 10 users. You see that this user here did not have any order, the second one. So I'm going to save this result. I'm going to pin it. And now, I'm going to do a lateral join to get the same thing. I remove this query. I put it in here as lateral. And I define inside. It's giving an error because the ID is not prepared because it's a new feature. And I will remove this. And I'll say this is equal as total order. And here, total order ID and total order dot total. Let me put total here. And I'm going to bring it up. And let's compare the results. There is a difference. Let me see. It's better to read, I think, to see the difference. So this one is the subquery, the one that the subquery brought. The subquery is always going to bring everyone that's on the left. It's like a left join. And whatever you have, if you have an order or not, it's going to bring it anyway. So it's going to show up as no. The lateral, it's a lateral join, functions as an inner join. So if it doesn't exist in both tables, it doesn't bring up. That's why the second one, 1155, does not appear here, but 1164 does, because I limited by 10, and it brought up the next one. That's how it works. And you can do other stuff with lateral too. Let's say I'm limiting here by 1. If I limit it by 2, what happened? I'm going to take this. If you limit by 2, it duplicates the lines like an inner join does, because it's like it has an inner join usually when you join a table that has many. You can bring up, I'm bringing here the top 2 most expensive orders per user for each user. So you can do that kind of manipulation that you couldn't do with a subquery inside the select. So which brings us to OLTP, Online Transaction Processing, which it is MySQL, Postgres, SQL Server, versus OLAP, which are other databases. OLTP stands for it's transactional. It's usually the single source of truth. It's normalized, it should be. And examples for that are MySQL, Postgres, and SQL Server, as I said. On the other hand, you have OLAP, which it is online analytical processing. You do aggregations with it. You do what we call star schema or cube. The cube is a multidimensional query to be able to create, the data is denormalized, and you can create analytics joining other tables, creating forecasts. Examples are there, Redshift, Pentaho. And BigQuery is not exactly an OLAP database. It behaves like one, it has features like one, but it's not. That's why it's not on the list. So what it makes query analytics, a query be an analytical query? Analytical query usually has, I say 2 or 4 of these characteristics. It has to have an analytical function, or using to two out of four here, or either an analytical function or a windowing clause, and have a partitioning clause which is like a group by, and I'm going to show you, don't worry about the names now. And yeah, order by clause is optional too, but it can be up to 4 ports. This is what it makes an analytical query. As I said before, window functions. When I discovered window functions, I was really happy because it made my job so much easier. What they can do, it allows you to analyze the results of a given result, rows of a given result set. Can behave like a group by, but you need to have this in your mind. A window function does not change the result set. It's not going to change the result that's bringing to you. It's going to analyze the result that's brought to you, but it's not going to change the result. Allows you to use a frame to pick over partition of a window. So it's like here you have a window, the outside you have the door, and you look outside of the door, and you can look right, you can look left, you can look up, but the outside doesn't change. Only your perspective change. It's what a window function does. Examples of window functions. You can enumerate rows just to count 1, 2, 3, 4, just to know, I don't know why you want to enumerate them, but you can enumerate them. You can show aggregated sums and rank results. So you can order by, as I order by the most expensive order, you can have a rank of that. And look at neighboring rows, which it is the most exciting feature for me, because I'm going to show you here. Because you can look like on the row that was previous and the row that was next to the other one, without having to run another query. This is my order table. I have ID, I have user ID, status, total, and created at, and updated at. Again, there are foreign keys, primary keys, and stuff like that that's not on the slide, but it's just to be able to be compliant here. And I apologize if it's too much to the left, and you know you're going to notice why. I'm going to say I'm getting all of the orders and from this particular user here, and I'm bringing all the orders, and I want to know when was the last I want to know for each order, when was the previous order. So if you are doing this, the result set is here. A window function does not change the result. So this result is not going to change. So if you're using PHP or Python, for instance, it's easy. You get the next one on the array or the previous one on the result set of the array, and you know the date, right? But if you're using window functions, you can get the previous order and next order on the result set too. Again, the results, I added columns, but I didn't change the result. It's still there. So if you look at the colors, you're going to see that the dates are the same. So at the second line, it's red because on the second one was the next order from the first one, but it was the previous order from the third one. So that's how it works. The first one is null because there is no previous order from the first one. That's why it's going to show as null. And the last one, for the same reason, there's no other order after that, so it's null also. Looking at the query that created that, it uses two functions, lag and lead. Lag is going to get the previous row, and lead is going to get the next row. What I'm getting from there, I'm getting the created at from that row, and the created at in order by, I need to create, so I wanted the date that was previous, so I need the date to be ordered. So on my partition, on my window, which is the over clause, I put in like order by created at. So breakdown, lag is the function, created at, it's the value of what you want. One, it's how many rows behind you want. You can get the first one behind, the second one, the third one, the fourth one, and so on and so on. You don't need to necessarily get the first one. And over a window, which in this case, a window was created by, it gets the results and internally orders by date and gets the date that you want for that row. Question?
Yeah, so the query that you just wrote,
No. No. Yeah, yes. No problem. But I'm said before, I'm lazy. I hate repetition. So I'm doing the window clause twice. And what if happens if I need to change the clause again? I'm going to change in two places again. What if I have other window functions here? So there is a thing called named windows. You create a named window which are named dates in both of them, and I define dates as created at. Window clause should be after the where and before the order by. Not necessarily, it doesn't need to have a where, but it needs to be before the order by or group by. You can have multiple windows on the same query. Here I only have one, but you can define multiple windows and use them on your query. I have a demonstration of that. So this is the query that was running that brought the orders for that user. I'm gonna get the previous and the next order, which it is the lag and the lead. I'm gonna put it in here. And as I said before, lag, created at, over the window, which it is order by created at, as previous order. And the lead, which it is created at, over order by created at, as next order. Oops, I put a so here is, I'm going to change the size. So that's the previous order and the next order here. I'm not bringing the total. What happens if you want to rank the rank of these orders here? You can say rank. Let me show the total. And I'm going to rank I want to remove the order by clause because when I rank, it's going to change the order. So I want to know which is the most important, from the most expensive to the least expensive. The rank doesn't receive anything over order by total descending, because that's what I'm going to get. Because I want to know from the highest order to the cheapest order as rank order. Okay, and let me see, because I lead changed the order. Order by rank order. So here is the first order. Actually, it's not the most expensive order. It's not the first one. If you look at the value here, it's like 18.8. Wow, this person's rich, $884,000. And then the first order itself, it's the third. So it changes the results. It didn't change the result set, as I said before. It changed how you display them, and it aggregates more information for what you have. So you can combine multiple window functions to bring up. Now, yes?
So in this query that you wrote, your lag and lead requires the where user ID is equal to the given user ID, or it can go with all the users, and I want only one row per user, say distinct user ID.
Yes, use the partition by. I'm using this because I have 50 million records there, and that I'm optimizing for the next one. Example is gonna have more users. Okay, no problem. So I'm gonna get this, and I don't want. I want to know now, given 3 users, what is the top 5 orders that user has. So I'm gonna start here with what Dave showed in the morning. If you didn't see, it's a CTE, a common table expression. A common table expression is nothing less than a syntactic sugar for a subquery. It allows you not to have to write a subquery. So in this case, you start with a with, and says the name, and then I'm gonna call it top orders, and you define it. This is the query that I'm getting. I'm gonna remove the limit, and I'm gonna get the user's ID that are in here, these users. But if I run now, it's not gonna work. You need to select the auto query from top orders. It's not gonna work because it's sorting by created at, and it could get the previous order from another user. That's a problem. So you do a partition by, which is like a group by user ID. That way you guarantee that's gonna be from that user specifically. If I run it now, I get it's out of order here, but like it's because it's ranking all the orders. See? Partition by user ID. So I'm getting orders from this user, and these other user here. But I only want the top 5, not all of them. And I have 27 rows there. As I said before, a window function cannot change the result set. But you see there is this auto query here. This is a temporary table in memory. I can query inside of it. So I can say that where rank order is less or equal than 5. And if you look here, it's not going to have more than 15 results. It's going to only have the 5 results for each user. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You see how big it gets easier? No, not easier. How easier it gets, how it's easier to get big, but you're running this against a database without having, and you get the result set as you want, and you don't need to do all those logics behind your application. But again, this is just to save your days, not for you to do every time. Okay, let me go back. I started introducing you to common table expressions. And what is a common table expression? A common table expression is similar to a create temporary table. It doesn't need a create privilege. You saw that I didn't create the table. It just said, I just declared how the table would look like. Can reference other CTE. So if I created a common table expression, I can reference another common table expression on my own query. It can be recursive. And it's easier to read than having all those subqueries, one subquery nested to another one. That's one issue that I had in the past, having like 300 lines of SQL of a select because it had subqueries on it. So it saves you from that trouble. A recursive CTE, it's useful for hierarchical data. I could show you here how to do Fibonacci with it, but like, what is the use case for that? Like, none. But as I said, hierarchical data is quite common, especially on blogs and e-commerce, because you have categories, subcategories, and each subcategory has another subcategory, and you sometimes want to traverse that tree and get all of the results at once. And again, if you're doing this with normal SQL and another language, you're doing probably on the language side, not on the SQL side. The recipe for a recursive CTE is like the base query comes first. What is my starting point? The second query, it's a union statement because you're gonna glue together two queries to create one. And the second one is a condition, is gonna have the recursion port and the condition stop. So this is an example of FizzBuzz on CTEs, but like, don't worry about that right now. This is what I want to show you. This is a store and has categories, and the products I'm selling, it's either for animal, plant, dog, cat, and they are nested. They're like a West Highlander Terrier belongs to Terrier, which belongs to dog, which belongs to animal. So how are you gonna do that on the database, not using any other language, scripting language? You're gonna have to do, if you're using a scripting language, you do a lot of queries all the time getting in. It's like the depth, the maximum depth is gonna be how many queries you're gonna fire to be able to traverse that tree. And here you can do it only one. If I can do it. Let's see. So, pardon me if I don't remember everything. I have a snippet here in case I forget it. So you start with recursive. I'm going to say tree, and I'm going to define this tree to have a depth level, which for me to know how deep I am on the recursion, so I can have a stopping condition. First, let me show you here categories. So it has ID, name, and parent category ID. So it's going to have that. It's going to have the name, the path. That's what I want to concatenate to know what is the path up from that line, from that row to the top, and the node ID. As, and there is a definition. So that is the definition of the recursive query, but as I said before, you need to have a starting condition. My starting condition is going to be, what is the depth level? I start with 1. It's the first record, right? So my first record is going to be 1, my depth level. My name, parent name is going to be root. But root here is a short. It's casting as a short with 4 characters. Animal, for instance, has more than 4 characters. So you need to cast it to a higher short. I'm going to put a short 255. And same thing happens with the path, because I'm going to be concatenating the path, but I don't know how long it's going to be, so I'm going to put the maximum. And node ID, it's going to start at 0 because my parent category ID, the first one, it's 0, the parent. If you do a select from tree, you get this. 1 row, root, node ID. Doesn't do anything for now. It's not recursive. It's not bringing results. As I said before, you need a union. So union all, and the recursive query, which is a select. I'm going to put store here because I need to do an inner join here from categories, where the inner join is on 3, which it is on CTE, that's why it's recursive, on 3 dot node ID is equal to categories parent category ID. Now I'm going to put the values that I want. So depth level, each time it iterates, I'm going to sum +1. Depth level is going to be +1. The name is going to be the name on the tree, so tree.name. Then I need to get the, let me hide this. I need to get the path. I'm going to concatenate, separated by slash, the current path to the, not tree name, it's categories name, to categories name. And node ID is going to be categories.id. And if everything is right, it should work. And it brought all the results. It's not easy to see, but I'm going to do a trick here that's going to be easier to see. Let's do a order by path to be easier to see. So it's easier there now. We have root, we have animal, and all the things that belongs to animal are in here, and all the things that belongs to plant are in here. That's how a recursive CTE would be useful on a production case. You can do that with, I have a code snippet I can share later. If a binary tree too, you can traverse the left and the right and get everything together too. So that's pretty cool in my opinion. And let me see. 11 only, it was just for purposes only. But there is a thing that let me go back there. I put that level because you need to have a stopping condition, and I'm gonna put the stopping condition where that level equal to 2, for instance. It's only gonna bring a couple. Wait, not here. It's in here. 2 is gonna be 2, not equal. Am I summing? Yeah. It's 5. Yeah. Okay. Or 3. See? Because there is a limit. I don't remember the name of the variable right now, but at the depth level maximum on MySQL by default it's 500. So you can have 500. You can increase that, but you should have your stopping condition before that. So 500 is a lot of rows to bring at once, in my opinion. Okay. So just to go for parts again, I have a tree. I set up root as I casted root as a char and root again as a char because I'm going to create a path. And once I do the first step, which is the base case, I put the recursive port, which it is this one in here. And it brings everything from that table. I have more stuff to show, but like, does anyone have any questions up to now? Yeah.
Different sort of question. What's the IDE that
Data grip. Data grip. Data grip. It's from JetBrains. Same one from IntelliJ. You're welcome. Yeah. Like it brings up the speaker game better. So what I want to show you is a query that I wrote, and it's in here. No, wait. It's in Files, Advanced Reporting. I'm not going to do this query because I already have the results in here, because it's too big. So I have here, no, it's not Advanced Reporting. Crash. Oh, it's in here. I already put it in there. So this is a lot of information going on in here. Basically what this query is doing is getting the average from the day the difference on average of daily average of a month of the store and comparing to the previous day and bringing up the aggregated sum. So let me show you, which is better than me saying. Oh, it's gonna take a couple seconds. I forgot that's a bit slow. Let me kill it. Let me do it here. It's gonna run. Any other questions while it's running?
Any idea when MySQL 8 will be available on Google Cloud SQL?
Oh, yeah, no. It's on the roadmap, but I don't know when. They don't tell me that. I'm just a poor employee. They don't tell me that. Okay. Okay, it ran. See, that's why you shouldn't do on your production database how long it took. If you notice here, I have the order date, which it is on January 1st, and the previous date average was the $14,000. That day average was $14,664. The previous total of the day the store makes a lot of money was on the millions, I think. And this is what I find it cool. This is the value accumulated day by day. It gets the value of the previous order and sum it. Gets the value of all the other ones and sum it, and goes on and on and on. And that helps you to see, create stuff like this. Like I created here. So this is a graph, of the growth of the sales you could do in here, because you have the result side of the accumulation. It can also do the average. This is the average versus the total that was sold. All of that generated with a single SQL query. So that's really powerful for me. And that's it. If you can reach me on Twitter, I'm a co-host on the DCP podcast. We talk about a lot of stuff. And my website is there. If anyone has any questions, thank you.
All right. Hello, everyone. I'm going to go ahead and kick off just about a minute early here. Just want to first kind of introduce myself. My name is Michael Marks. I am a Principal Solutions Engineer for MySQL, also known as Oracle. And so what I do in this role is I work with a lot of different organizations that actually purchase a commercial license of MySQL. And I work with them to try to determine how to actually implement solutions in their environment. We do participate a lot in the open source stuff. Some of you who may have been here earlier for Dave Stokes probably has seen him a lot more than someone like myself. We tend to do a lot of private events, but occasionally we do get asked and invited to come speak at things like SCaLE. This is my first time speaking at SCaLE, so I'm pretty excited about it. So as Dave went on this morning to talk about, and for those of you who have never seen a presentation from Oracle before, this is just something that Oracle requires us to show you. Some of the stuff that I will talk about today does relate to our commercial product, and if there are any questions, some of it may be about things that are in works for our commercial product. And so as a software development company, and those of you who work in software development know that what is your golden product today may not never make it to market. So this just kind of protects us. So in case you get mad at Oracle and try and sue Oracle for a product that I said was there, this is what kind of protects Oracle from that. All right. So I was kind of Googling around, and I was trying to find this type of headline, and just out of curiosity, out of a show of hands, who has actually seen a headline like this regarding an organization? Well, this is a real positive one. So this is one that they protect your data. For me, I couldn't find anything on Google, which is, I mean, most media outlets aren't going to report when your company does something positive. They're going to focus on when you do something negative, like this. This was actually very easy for me to find on Google. The other one I searched using Google, Yahoo, Bing. I tried to find something, I couldn't. This was a very badly formatted Google search, and it was the first thing that popped up. And sadly, these type of headlines are becoming more and more popular. This is just something I found online of putting together just in the last couple of years of all the organizations that have had a data breach. And some of these are just outrageously high. I mean, Yahoo at $500 million, and then looking at like LinkedIn at, you know, a little over 100 million. And so these numbers, to me, like some of these are just insanely huge for different breaches. Now, I don't know, for those of you who are from Southern California, I don't think there's anyone here from this company, and I'm just putting this up here because this company actually had a breach that was very well documented online. So I'm not picking on them. I know a lot of people who work here. It's a great company. But this company was one of the companies last year that was actually involved in a very large data breach. I forget the number exactly, but it was somewhere around 300 million individuals. Now, for those of you who don't know AlterYX, they do a lot of analytical type stuff for a lot of different businesses and organizations. So if you wanted to find out something about consumers, this is one of the companies you'd probably go to. And that's exactly what this organization was doing. So this organization was actually compiling information about us, consumers. Yeah. Okay, sure. Yeah, so they were actually compiling data about consumers. And what they were trying to do is they were trying to help organizations figure out buying patterns. Now their data, they were actually buying that from Experian. So both Experian and AlterYX, both of these companies pride themselves on being very secure. But they made a simple mistake. what they were doing is they were putting their data to transfer it to each other in S3 buckets. And now I don't remember exactly if Amazon still has this issue. I think they may have fixed it, but I could be wrong. But what someone found is that if you have an AWS account and you find the path to an S3 bucket, you can put that in your browser and see everything in that S3 bucket. And that is exactly what happened to AlterYX. Both companies, great due diligence on their sides to keep their data secure. Unfortunately, they got hit by a vulnerability in an S3 bucket. So they put out their data there. Someone went, put in that path, was able to get all their data. And it was basically a backup. So that's kind of the goal of what I wanted to go over today. A lot of this stuff, some of you probably already know, maybe some of it's new. But I really want to see what we can provide you to help you guys from ending up on the front page like Twitter or PayPal or something like that. One thing, just a couple caveats. I do have typically I do run a little long when I talk, so I'm going to try and speed it up since they gave us about an hour here. Also, the stuff that I cover is covering specifically MySQL 8.0, and I also throw some things in here about the enterprise. There are some organizations here at SCaLE, for example, like Percona, that do make some alternatives to this, but the things that I cover in here are going to be generally specific to MySQL 8 and the enterprise. Most of it's available in both enterprise and community, so you can use it in both. And most of it's pretty well labeled, but if there's something that I see that might be a little bit off, I'll make sure to point it out. So when I first started working with MySQL, and I've been working with MySQL for close to about 16 years now. I started working with MySQL back in 2001. And one of the things when I was transitioning into the database role, coming from a development role, was trying to understand security in MySQL. Most database systems I worked with, like Ingress, AS400, those type of database systems, they had very simple protocols for users. It was just basically a username and a password. MySQL kind of threw in a host name. So as I was trying to learn this, there was a guy that I worked with named Brian Acker. Some of you may know him. He's pretty popular in the MySQL community. But how he kind of explained security to me was through what he called the impenetrable maze. And basically what this is it's layers of security to actually make a robust security solution in MySQL. So it includes the outermost layer, which is network security, followed by the operating system, followed by the file system, and then into your user security, which is around MySQL. So what I'm going to do is I'm going to actually cover a few things that are pretty popular and best practices to do in each one of these elements. Now, one of the questions I got when I was doing this presentation in Las Vegas a few months ago was, why do we call it the impenetrable maze? And part of that is, if you notice the little gaps in there, those gaps were put in there on purpose to make it a maze. And the reason for that is because each one of these different layers does have some type of hole in it. It's not 100% foolproof. So in order to actually get absolute security, you have to address each one of these areas, each one of these layers in there. And so that's why it kind of came to the impenetrable maze. This is a very old one. If you see some of the old material like Dave Stokes used to write, they put some stuff in there about this. And it stuck with me for almost 2 decades now. All right, so going into security measures. So first one is around just your firewall. This is kind of basic 101 for most environments, especially when you look at MySQL. MySQL is traditionally used for web-based properties. You look at some of the big advocates of MySQL out there that tend to block about it. GitHub, Facebook, Pinterest, Zendesk, Yelp, these are all web properties. And once you start allowing people to connect remotely to your MySQL server and have multiple users, it's a security risk. So it's always great to have something in place to kind of help block some of that at the connection layer. And so one of these is actually putting in a firewall or having a very secure location in your data center. A lot of times you'll hear the term demilitarized zone or DMZ, and those are fairly popular. Another one is to restrict client access to MySQL. How many DBAs do we have in the room? Oh, none. Okay. Oh, yeah. Hallmark. So one of the things, and I'm guilty of this too, is that when you're creating users in MySQL, it can be a tedious thing, a tedious exercise to constantly do. So one of the things that gets easy is to basically put a wildcard in there when you're creating your user. Like, I just want to allow them to connect from anywhere. I don't want to worry about all their hosts. And that's just bad practice. Ideally, you should be putting in an exact host name for where that user is going to be connecting from. Now, there are tricks that some people do where you can put subnets in here. You can put part of an IP address. Various different ways that you can mimic this to actually increase the range. But each one of them still kind of leaves some gap in security. So ideally, when you're creating users, it's always best practice to actually put the full IP. So if you have a server farm with like 100 users in there, unfortunately, it's probably best practice to create 100 separate users. There's an organization that I was working with not too long ago that had an attack on their server, and someone gained access to it for a multitude of reasons. One of them was a simple password, but they had put in 10.%. That's a very common IP address that anyone can easily get. And so someone was able to use that to exploit their server. So a good thing is always tie it into a server. With that also is to bind addresses. So this is something that I don't see very often anymore, is to actually bind the address to a port. There's actually a couple malwares out there that have been found that will actually attach themselves and create network devices that allow connections through it. And so the default for MySQL used to block this to just the local host. And then it opened up to basically allowing, it listens on all the network devices. Ideally, you should narrow this to a specific device that communication is going to be coming through. It's just an extra layer of security. Its exploit is probably pretty low. I've seen that, there has been a few malwares in recent history, but it's one of the rare attacks that I see, but it is possible. Also in 8.0, we introduced what's called an admin address. So for those of you who may have been working with MySQL for a really long time, one of the common problems with MySQL is that if you exceed a certain number of connections, you can no longer connect to the server. Now there's an exception to that, is if you're a root user, you can connect to always one reserve. So if you say 500 users, it's actually 500 plus 1. Well, what we've done and what we found is that sometimes people give application users administrative privileges, and if you exceed your max connections with a super user or an administrative user, then you can't get in with that +1. You have to figure out some other way. I know there was a blog post on Percona a few years ago on how to use GDB to do it, but what we've done is to make it easier and simpler, instead of having to use a tool like GDB, is you can configure this admin address, which is basically a specific port that you set up on the server that allows administrative connections. And this will allow as many connections through it, but only admins can connect on that address. Disable DNS. This is something that I know in the community, in the MySQL community, got really popular from Baron Schwartz. He blogged about it all the time. He wrote it in his book. And I really love the way he described it as being kind of the DNS being the Achilles heel of a MySQL installation. Ultimately, the biggest problem with this is just, for a lot of times, is performance. DNS can be slow. and if you are doing name resolution, you're introducing that slowness into your database because we have to transverse the host name that comes in. This can also be used for DOS attacks. So having that enabled, it makes it a bit easier for someone to basically DOS your MySQL server. So the best practice is typically to add this variable to your MySQL conf, which is to skip name resolve. I do know that this is a little bit problematic for those of you in AWS because sometimes their IP addresses are very dynamic. So, but this is definitely one that is generally a best practice. Also, as I talked earlier about setting the max user connections, this is definitely something that you want to do on your server. A lot of times when you're building out a new application or installing a new MySQL server, it gets kind of difficult to really kind of understand how many connections you really are going to have towards the server. But this is one thing that I do encourage, that when you're setting up your servers, you really find out how many connections are possible and make sure that you set that. Now, the nice thing about this is that it can also be set at the user level as well. So if you want to, you can actually set user constraints on users. So here is one with all the different options available. So if you have particular users that you know can access to the database, or if you have particular processes that you know that are going to access the database. So for example, a cron job. So cron jobs usually run maybe once a day or periodically throughout the day. Anyway, you kind of know how many times it's going to run. Now, whenever you have a user account running from a cron tab, there's a risk that the password's probably visible. I would say 9 times out of 10, I go into environments, I look at cron tabs, I see bash scripts, I see passwords. Those are very easy to exploit. So what you do is if you limit those users, this just provides you some extra protection. If someone were to get on to that server that's running that bash script, well, okay, so maybe they run queries a few times, but you're going to limit them. And once they exceed that, no more. And you can monitor these users too as well. And so if you start seeing connections from them, you can set up alerts around it. These type of things you can set up through, if you want to use MySQL's Enterprise Monitor, you can use that. Or you can use things like Datadog. I think Vivid Cortex will allow you to do this as well as I think you can custom make something in PMM as well. I'm not 100% sure. This is one that's been around for a long time, which is disabling load data. So this is where, from local clients, this is where if you have a file on your server, you can actually run commands to load this right into MySQL. When you have the local aspect of it, what this does is this allows you to actually execute it locally. Normally it wants to run it locally from the server, but if you put in local, it will pull from the client. Because you're reading a file from the operating system on the client, this does expose you to a lot of different risks, especially if someone were to sign on to, say, an application server, and they were to run from the application server etc password or something like that. So they could pull certain files from there. So this is one thing that is highly recommended to be disabled. As of 8.0.2, this is off completely by default. Also, encrypting connections. So with MySQL, we actually use TLS, which is the Transport Layer Security Protocol, for actually encrypting connections. We still use like SSL, certs, and so on, but we do the encryption using TLS. Highly recommend that when you're dealing with traffic on MySQL, that you just encrypt it. And it's actually fairly easy to set up. Realistically, to set it up on the server, all you have to do is put in a few configuration options that represent your PEM file, your private key, and your public keys. And then when you're making connections into the server, you can actually specify the PIM key, but then supply the private keys for the connection. And just to note, those are two different things. So the server cert and the server key are different from the client ones. And those will live on the client. One of the other things that we do through MySQL to help enhance security, and this has some extra benefits, is also helping to manage all those users you might be creating, is that with MySQL, we do have in the Enterprise Edition what's called Enterprise Authentication. This is a plugin that allows you to use your LDAP infrastructure, Windows authentication, or PAM authentication to authenticate users to MySQL. So there's definitely some benefits there. The high-level architecture of how it looks for each one is quite simple. So with network security for PAM authentication, basically the client would just talk to MySQL. MySQL would just validate that user actually has an account and authenticate them. With Windows authentication, works almost exactly the same, except for you do have this extra round trip where it validates the Kerberos token. So it's just one extra step in there. But for the most part, it works exactly the same. Another thing is to not trust what you allow users to enter into MySQL. So this is for the developers in the room. This is the common thing, is sanitize your inputs. If you have a form that allows users to enter information, don't trust it. Technically, MySQL community and some of the stuff out there, I haven't seen a whole lot of stuff built for the databases at an open source or free level that actually provides some protection for this. Most of the time, it's just developers need to use defensive programming to be able to make sure that they protect data being entered in by users. Now, the MySQL Enterprise, one thing we did come up with was a firewall, which has been around for a while. And this works very similar to a firewall that you would have for, say, your data center. But we use it for SQL. It sits on the database. It doesn't require any changes into your application. All you do is it automatically creates a whitelist of queries. And then any queries that don't match that whitelist, you can set up rules for it. You can block it, you can block and alert it, you can alert it, or you can just let it pass. Ignore any, if it's in the whitelist or not, you're going to let it go through. I use this, I worked for Disney for a few years, and we actually use this to keep our developers off our database boxes. Because we had taken away all their privileges to the databases. A lot of developers got upset about it, but they found a loophole. They found out that, oh, we know how to access the application server. We know where all the configs are, so let's sign on to the application server and run our queries. Unfortunately, those queries were very bad for the database, brought down the server several times during production. So what we did is we set up the firewall, and if any of the queries came that didn't match what was in our whitelist, they got blocked. So eventually our developers stopped doing that. But there's many use cases for that, but SQL injection is kind of the main reason why we have this. All right, yeah. Yeah, so basically the rules are you can block it, which means that if the query comes, so what happens is there's a few stored procedures, and when you're setting up a server, if you think of it from like a new application, you turn the stored procedure on, which is almost like hitting the record button, and then you run your application code. When those queries come in, what we do is we create a table, we hash those queries, we do predicate substitution, we just hash the query, and so as long as they match. So if you see it here, kind of that top one where I have select all from employees where employee ID equals 22. So what we would do is we'd hash that, and if that query came in again, it could say 11, it could say 120, whatever, it would go through because the hash matched. Now, The bottom one is kind of a classic SQL injection, where you're just going to append this or 1 equals 1. So if we see that come through, it doesn't match the hash, so we can block that. And that just, it basically sends a message back saying, no, we're not allowing it. I forgot the exact message you get back, but usually if you're using like PHP, you'll get a PHP exception thrown for that. Now, but like I said, you can block and log. So this is basically blocks it, and then it logs the transaction in the error log for you. You can allow and log, which means it doesn't match, but we're going to log it anyway, just so you can come back and look at it. If you're using our enterprise monitor, you can actually set this up to send out an alert on warning. So if someone were to come through, we could immediately send out an alert to your DBA staff or your SRE staff or whoever's managing it, and basically say, hey, this query came through, we allowed it through, but we wanted to let you know. And then you could go through and change the rules on that, or you could add it to the whitelist. But they're pretty simple. It basically comes down to block, allow, or nothing. It's just pretty simple. Cool. Now some operating system stuff. So one of the things is to reduce the number of services running on MySQL. So this is probably has become a more popular subject in security. I know that some of the different requirements out there, like PCI and I think SOC 2 and those, they have pretty strict requirements that database servers only be database servers. And that's great for just minimizing the number of hands on the server as well. Stay up to date. This is actually, in fact, I think I provided the link in there. So for like PCI, and I forgot, I think it's requirement 6.1. So in the PCI standard, they actually require that your server be up to date. And so that's just kind of one of the big requirements is make sure you're constantly up to date. Software today, especially in kind of the new world of development, there's a lot of continual development. I know at MySQL we've decided to go towards a continual development model. So you're constantly seeing new software updates being pushed out. Unfortunately, there's an increase in bugs when you do that. Sometimes those are security bugs. So it's always good to make sure that you stay up to date so you know when those have been repaired. And at least your server stays up to date on that. Next one is how to run MySQL. So luckily I don't see this as much anymore. I used to see a lot of companies, a lot of organizations that would actually set up their MySQL service and have it run as root. And this is more specific to like Linux environments. A lot of times Windows, it's always been kind of a standard practice to create a user in Windows environments to run it. But in Linux environments, we do see a lot of times when, especially when individuals do like tarball installations or source installations, that they actually run everything as root. And so we highly don't recommend that. Definitely, we recommend that you create a group and a user for MySQL. This is actually, if you install an RPM, this is done for you already. But if you're installing MySQL yourself, just make sure that you don't allow that user to log in either. So that's just a simple command that doesn't give them a shell to be able to log into. So even if someone were to compromise this user for somehow, they would have to be on the server to be able to use it, and they wouldn't be able to start a shell for it or anything. Some file system security. This too, if you're doing the RPM installation of MySQL, this will all be done for you automatically. When MySQL installs, it actually sets permissions on those files as well. But the bottom line is that MySQL should be the only one that reads MySQL files. Don't open it up to anyone else. Keep the permissions on those files to MySQL. including configuration files, log files, data directory, whatever files you have out there. They should be specific to the MySQL user only. So this is one related to privileges around the file privilege. So MySQL does have a file privilege that allows you to output data into a text file by using the load data or the select into to be able to output files. This is a pretty powerful ability to do in MySQL, and so it's generally a best practice to really limit the number of people that you actually give this privilege to. In fact, I believe we introduced it in 5.6.30, I think it is somewhere in that range. We actually set this new variable called the secure file privilege. And what that does is that actually limits what directories on the operating system that data can be outputted into. So if you were to do a select into out file, you would have to put it into whatever that directory is. A lot of times users would find different directories that they could output data in because of maybe space. A lot of times people would put it into temp. The problem is that you could dump data into anywhere you want to, which could pose a problem. Also, a lot of times if you put it into temp, if you put in sensitive customer data into temp is usually very wide open. Anyone can go in there and read it. And if you forget to clean out what you've done and someone gets on the database server, it just kind of gives another place to expose data. So this allows, especially for like DBA or whoever's managing your data, they can actually create a location and specify this is the only place I'm going to allow data to be outputted to. The default is, I believe it's in the var data or the varlib data or varlib files or something like that. It's one of those. Another one is that's actually been getting fairly popular in the last, definitely the last couple years, has been protecting data at rest. So we hear about it every once in a while. I'm sure most of you probably have things in your own organization just about, actual theft of like a laptop. Someone walking off with a laptop, taking your hard drive out, and then reading that hard drive to get data off of it. So a lot of organizations have started using encryption functions on laptops. So at Oracle, they use like BitLocker, and I know some of the Microsoft machines, or the Apple machines, you can encrypt your data directory there. But it's a lot of times people who have MySQL installations, a lot of organizations, they don't actually encrypt the data on the file system. Now, this one here is, there's a lot of solutions out there for it. Some of the common ones are like the ones through Red Hat. Red Hat has one. Vormetric has one. Difference with those is those are full disk encryption, so they're going to encrypt the entire disk. Downside to it is, depending on how chatty your application is with your server or how busy it is, these can introduce a little bit of overhead. And so one of the things that we wanted to do at MySQL, and we actually brought in a bunch of guys from a company called Gazang, was to create what we call tablespace encryption. Now, we offer two types of tablespace encryption. So the first tablespace encryption is what's available in MySQL. So if you go and download the community edition of MySQL, you can use tablespace encryption right away. And what this does is this gives you the ability to encrypt the data that you want. So if you have, for example, say you have two tables, one table with customer social security numbers and one with states. Most likely, no one's going to really care about the state. It's public knowledge. You can go to Google and find every state if you need to. If someone steals that from you, okay, they know every state in the U.S. now, no big deal. But if they steal your Social Security one, that can be a problem. So you can just encrypt that in MySQL. Now, the other one we have is through our Enterprise Edition, which is called Transparent Data Encryption. The reason why we have the name difference is because the Enterprise Edition is the only one that actually fully supports transparent data encryption. So table space encryption creates an encryption key, but it stores it locally on your hard drive. Not very secure. So some organizations that I've seen that have implemented table space encryption, what they do is on startup, they just unmount that drive, but it's still there. It provides security through obscurity. If someone was smart enough and came in and looked for drives that are there, they could just remount it and they have the key. What this does is this actually works with Key Vault, and it allows you to store the key off the server. It also allows for others to manage it, not your DBAs. So the whole concept of lock and key. This actually allows your security group to actually manage the rotation and the management of keys. All the DBAs need to do is make sure that the database can make the network connection to get the key on startup. Now, some of the stuff you'll see if you go and Google this or look on our website, you're going to see a lot of mention of Oracle Key Vault. Yes, we work with Oracle Key Vault. Yes, we test on Oracle Key Vault. But being part of the Oracle family, they push us to test that. However, the Oracle Key Vault will work, our transparent data encryption will work with most key vaults out there. There's a protocol called KMIP, and as long as it's version 1.1, you can typically use that. So some of the popular ones are like Gemalto, AWS has a key store. So there's different key stores that you can use. There's some open source ones out there. There's some very expensive ones, but you can use them. So don't get scared if you see kind of a lot of the, you got to use an Oracle Key Vault. You may be able to get a discount, I don't know. But it will work with almost any key vault. Cool. So heading into kind of the last part of it, of just kind of some of the user security. So for those of you who aren't real familiar with MySQL users, so the way that we create users in MySQL is we have different levels of access. And so at the very top we have global access, and then we go down from there. So database, table, column, and then your programming objects like stored procedures and triggers. Those are the different levels of security that you can create. Now, one of the things that we do suggest is that when you actually create accounts, you actually make sure that the users that you create have the necessary privileges to do their job and nothing more. So I worked with Grubhub for a while, helping them when they were setting up their servers. And this was actually one of the big things that we had to focus on. A lot of their system was had a lot of user accounts that were very wide open. And so one of the biggest things was actually making sure that every user only had the privileges necessary to do their job and nothing more. So for example, they use Cassandra quite heavily for their front end, but they ingest it into MySQL so like accounting can read the tables. So what they would have is the process that would come from Cassandra to write to MySQL only needed to do inserts, updates, and deletes. That's it. So those were the only privileges that we gave those accounts. Nothing more. They couldn't select or anything. And that just kind of really helps with security. There's also quite a few of global privileges that be careful when you give people all privileges, because shutdown is one of the privileges they have. Someone can accidentally shut down the MySQL server. Process and super privileges, which gives them access to everything on your server. One of the other ones is grant tables. Sorry. Yeah, so these are just some tables that you can use for looking at how your permissions are set up in MySQL. So in the MySQL database, there are several different grant tables, and those grant tables will you can use to actually better understand your privileges. So a lot of users that I see what they tend to do is they'll use they'll run some command where they'll try and show the grants for every user, and then they kind of parse through it. Either you write some fancy tool to do it, or I know Percona has a pretty cool tool in their toolkit that allows you to pull out the users. But if you wanted to actually write a query for it and see it a little bit easier, you could actually query one of these tables. You know, so like the columns table is going to show you what privileges users have on a column. And this just makes it a little bit easier because you don't have to write anything. If you're lazy like me, you can just run one simple query. Passwords. So I think the first one is, I think, pretty standard. Anytime you create an account, make sure it has a password. In fact, in the newest versions of MySQL in 5.7 and 8.0, we don't create any accounts now without passwords. And by default, we have a harsh security model set up that requires users to be created with passwords of certain standards. Also, on new versions of MySQL, when you actually install it, there's a temporary password that gets created. The server is actually locked to not allow any activity on the server until the root password's been changed. Once the root password's been changed, then you're able to do anything you want. There's also a validate password component that was added into MySQL, and this allows you to actually add some extra security around your password management. This is just an example of, well, these are the variables that you have access to with the password validation. So you can now set up rules around creating passwords. So if your organization has a requirement that all passwords have to be 10 characters long, you can change this to be 10 characters. And so this will require that all passwords created be 10 characters. You can also specify the casing of it, how many numbers have to be in it, and if any special characters have to be there. So you can actually specify this at a global level so that when you create users or if you hire a new DBA, they won't be able to create anything that's outside of your company standards. A lot of environments that we go into, this is actually one of the areas where we see a lot of differences between the organization and the database. Is because MySQL really didn't have this in earlier versions. It was very easy to create users with things such as password or 1, 2, 3, 4 or something like that, where a lot of times your Active Directory was going to require you to put in a 80-character string or something. So now you can enforce it on the database. There's also some other password management capabilities that you have. So you can now, in the newest version of MySQL on 8, you can actually keep track of passwords historically. So one of the cool things, and I remember when they first introduced this, it caught me by surprise because I was one of those people that wanted to just reuse my old password, but I tried to change it and I couldn't. It said you can't reuse a password. So this is something we've actually introduced in MySQL. Another thing that helps eliminate that bad habit of trying to reuse the password. Now you can actually keep track of that history. You can also track how far back you want to go and how long you want to wait before they can reuse that password. One of the cool things on here that I've noticed is the second line from the bottom, the dual passwords for MySQL. Has anyone heard of this? I've been curious to see if anyone has started using this. Just by show of hands, is anyone using 8.0 yet? Or no? Okay. So in 8.0, we added what's called dual password. And actually, did I have that on here? All right, I think I have a slide on the dual password, so I'm gonna just skip on that one for a second. I will come back to it because it is a really cool feature, but I think I have a slide coming up on it. So just going into the password management, there's the ability to do the password expiration. So this is where you can actually create a password and set it to expire as DBAs. One of the nice things about this is that it always becomes a challenge when you hire someone new, a developer, a DBA, DevOps, and they need access to the database. How do you give them their password? You know, basically you have to create it for them, give it to them, and then rely on them hoping that they're going to change it. A lot of times, 9 times out of 10, the users just keep that password for the rest of their life. What you can do now is you can create the user, give them a password, but set it to expire, so as soon as they sign in to MySQL, they have to change it. They have no choice, but they have to change it at that point. You can also set an expiration for it. And one of the things that you'll notice as I start getting through these slides is that you can do it at the global level, so apply it to the entire server, or you can actually do it specific just for a user. So a good point is with applications. Most organizations don't want to change their application user accounts every 90 days. So what you can do is you can actually set a much higher value or just leave it to no value at all to where it never expires. But as part of the practice, create it for your users. When you create users, like a developer or a DBA, require them to change it every 90 days. So that's one feature in 8. Next one, this is the one I was talking about on be able to reuse the password. So this is one where you can set up the history and how long you want to wait before they can use it. This password reuse interval, that is in days. Exactly. I hated that the first time I saw it. Like, oh, I want to reuse my password. Yeah, you got to remember it. Then you end up with stickies all over your computer, like, oh, what's my password? So another one is for, specifying it, again, for the user. So you can set globally, you don't care globally, but per users, yes. You want to make sure that you retain, 5, and these are occurrences, so 5 occurrences. So after 5 occurrences, they can reuse the password again. This is one for, I'm sorry. Oh, this is just one to require, this one caught me off guard. I don't see this one too often. This is just to require a password on the start of the server. So when you start up the MySQL server, when someone connects to it, would require a password for it. And once again, you can actually set this up at global level, or you can do it per user. And then this is where I get into the really cool piece, and I'm actually just going to get to here, because this is, so for those of you who have worked in environments where you have hundreds of thousands of application servers, when I worked at Disney, we had an environment to where we literally had 250 application servers for multiple different systems, and a lot of times their passwords were all the same. The hardest thing is whenever our auditors told us we had to change the password, because basically it was kind of like what comes first, the chicken or the egg. And that's what it came, is where do we change it first? Do we change it in the application first and let all the connections die? Or do we change it in the database and then allow all the connections to get denied? So it was a very tough obstacle to do and challenging to try and figure out the best way to do it. So in 8.0, we actually introduced dual passwords. This means a user can have 2 passwords at one time. So what you can do is you can actually set the password for the user, give them a new password, say to retain it, go through, change it on your application servers, and then start going through here and deleting the old password. That way you don't ever have any downtime. You don't have to take an outage for it. You just have to change the password on the application server, and this will actually use both of them. So you want to fix this as soon as possible. You don't want to leave it like this, because what this means is that if that user tries to connect to MySQL, they can connect using either password. Doesn't matter which one. They just, either one they can use. So this is actually one of my favorite features that came in 8.0. And it's one of the ones I wish would have came out when I was at Disney, because that would have made my life so much easier.
Can I buy one of them?
Yeah, actually if you see the bottom, so what you do is, so you take the password, you create the new password, and then once you've gone through and changed it on all your application servers, then you can go ahead and just discard the old password. And then that just basically deletes it out of the grants table.
No, I meant like, let's say like the old password I say expired after certain days or something.
Oh. Yes, so what would happen is you could still have the rules in here to expire it. So when you create that initial one, it will actually create an expiration for that original password, which will be the same. You could alter it before you change it. So if you wanted to change it, alter the user first, say expired password, X number of days, like 10 days. Then you can go through here and change it and have it expire, and it goes through. Now the only thing is that if something tried to connect using it, they're going to get prompted with, hey, do you want to change your password? And then they have to put in their old password, which was this one back here. So this one here, password required on current. So what this means is that if their password expired and they connect, this says, yes, enter your old password first, and then you can change the new one. Yeah. Cool. And then I just got about 2 minutes here. And basically, I just have a few noteworthy mentions around MySQL. Just a couple things to point out. So first one is we have completely deprecated symbolic links in MySQL. So those are not an option in MySQL as of 8.0. Always suggest when you download MySQL, make sure you validate the key, especially if you download from any of the MySQL forks out there, whether it be from us. We include a GPG key that you can download and validate that your binaries are good. I know Percona does the exact same thing. MariaDB does the exact same thing. Always make sure that you do that before you download software to make sure it's trusted. Backups, as DBAs, or if you're a steward of data, your RPOs and RTOs, which are your recovery times and recovery points, I'm amazed at how many people don't know these. And these are just key to every infrastructure to know first off, if we go down, what's the requirement for me to be back up? How much data am I allowed to lose? And that will help too when you're developing like your backup plans and strategies, recovery strategies. Also testing your recovery strategies. So, I've worked for many different organizations. We all had different standards for it, from doing them quarterly to yearly. But it's always good to test it and to time it to make sure that you can actually do it sufficiently. And then encryption of your backups. There are some tools out there that you can use to encrypt it. We actually make an enterprise backup for MySQL that does encryption of your backups that you can use. A few other things just on the enterprise side for security that I didn't really talk too much about. We also have enterprise encryption. I wouldn't say this is a really used product in the enterprise edition, But what this does is it extends out the libraries in MySQL for encryption. So for those of you on the development side that have had to do encryption in MySQL, you probably know that it's not a strong suit and the library is available. This actually adds in some ability to do security using private and public keys. So basically you can set up keys on the application side, so you don't have to pass like a salt or anything like that back and forth between the server and client. You can do it just through keys. So that adds a little bit of extra protection there. And then of course our enterprise audit. I know Percona makes an audit as well. We also in the enterprise edition do have a enterprise audit, and this allows you to record what people are doing on your databases. So if you want to see who selected 1,000 credit card numbers into a file, you can go through here and see who did that. There's a lot of different options there. So I am definitely proud of myself that I actually completed before I was supposed to. Last time I went a little bit over. But definitely, if you have any questions, comments, want to make fun of me, insults, go for it. I'm open. Also, I do want to put this first slide up here. As I said earlier, I do some of these conferences that I speak at, like the PHP one, but a lot of times because I do work on the enterprise side, Oracle likes to pimp me out to those who will pay for me. Unlike these events where they're more open source and you know they're not going to pay a whole lot to bring us out. But so I'm not sure the policy. They haven't told me yet on how to get this slide deck out to you. That is my email address at Oracle. And I normally you wouldn't see the middle initial there, but I used to work for Oracle in professional services. I quit, I came back, and unfortunately I got the P stuck in there. But that is my email address. Feel free to email me. I can send this PowerPoint out to you. Also, if you have any questions related to MySQL in general, feel free. Also on the enterprise side, I am not a salesperson. I do work with a lot of them. So if you have any questions around the enterprise, feel free to send it to me. I'm not going to pass off your information to a salesperson unless you ask me to. Purely just, if you need help, I'll help you. If it makes a good solution for you and you want to try it out, I can even set you up with how to do like your POC and help you out. And if you decide you want to buy it, then we can get one of them engaged, and then they can beg you for money. But yeah. So, any questions or anything? Yeah.
I had a question about the LDAP plugin for auth. How does that work? Does it create a local MySQL user in the table with its own privileges? Does it do it by nodes? How does it store it out?
Yeah, so basically what you would do is you would actually create like a MySQL user, and then you would, when you go through to create like your groups and stuff for like LDAP or something, you would just include those users into it. If you want to, there's a pretty lengthy instruction on how to do it. If you want to email me, I can send you the link for how to do it. But yeah, it doesn't actually create the users automatically for you. You do still have to create the user out there and assign them to that group. The nice thing in 8.0 that I forgot to mention, we did introduce roles. We actually introduced them in 5.7. So now you can create roles in MySQL, and those will work with the LDAP authentication and Windows authentication as well. Which makes it so much easier to actually manage those users now as well. So. Cool. All right, well, we have 3 minutes. I'll be up here for a few minutes if there's any questions, but yeah. Yeah, thank you.